Ok, benvenuti nella traccia panino dopo il coffee break. Ora Simona Pizza. Siete nella sala giusta.
Era un test.
Bravissimi. Ok, ora Simona Mazzarino ci presenterà il talk di come presentare la privacy dei dati personali nell'era dell'AI, un approccio pratico con NERPI. Grazie Simona.
Grazie. Ciao a tutti, io sono Simona, sono data scientist per Clearbox AI e in generale noi ci occupiamo di dati sintetici e di privacy. Oggi appunto sono qua per parlarvi di come cerchiamo di preservare la privacy dei dati personali all'interno di dati strutturati. Prima però faccio un piccolo riassunto di cosa sono i dati sintetici, come si generano, eccetera. Le slide sono in inglese, così se qualcuno, insomma, per qualche ragione si trova qui, non sapeva che il talk era in italiano, può seguire le slide in inglese. I dati sintetici sono sostanzialmente delle copie finte dei dati originali, che però mantengono appunto le stesse proprietà statistiche e le capacità predittive dei dati originali. Sostanzialmente possiamo utilizzare i dati sintetici negli stessi scenari in cui dovremo utilizzare determinati dati. I dati sintetici vengono generati attraverso dei modelli generativi, possono essere dei VAE o delle GAN. Il processo diciamo, che si segue quando si devono generare dei dati sintetici è un po' quello che vedete riportato in questa slide. Sostanzialmente quello che si fa, si ha questo dataset di dati originali, prima di passarlo al generatore quello che facciamo è fare un'analisi dei nostri dati originali per estrarre metriche, insights dai dati, in modo tale che poi queste metriche che abbiamo computato sui dati originali possiamo andare a ricalcolarle sul dato sintetico e poi fare un confronto tra quello ottenuto sul dato originale e quello ottenuto sul dato sintetico per capire se il dato sintetico è effettivamente utile e mantiene le stesse caratteristiche del dato originale. Una volta che sono state estratte queste metriche si passa poi al generatore e appunto si ottengono i dati sintetici con cui faremo poi la comparazione col dato originale. Questo è un meme che spiega bene che cosa succede, più o meno. C'è il modello generativo, il dato originale e poi c'è questo, che si capisce bene, insomma, tutto il processo. Quando generiamo dati sintetici bisogna chiedersi perché vogliamo generare dei dati sintetici. E diciamo ci sono due motivi principali. Il primo è la data augmentation. Vi sarà magari capitato di lavorare a dei modelli però su use case sbilanciati. A noi capita di avere dei clienti che hanno bisogno di aumentare i loro dati, magari perché stanno lavorando su progetti di fraud detection e quindi la classe minoritaria in questo caso sono le frodi, sono molte di meno rispetto al dato non fraudolento e di conseguenza hanno bisogno di aumentare queste casistiche di frodi in modo tale che i modelli che poi vanno ad addestrare proprio per la detection delle frodi insomma riescono a imparare meglio. Quando si generano dati sintetici per data augmentation, la metrica su cui ci si concentra è l'utility o la fidelity. Sostanzialmente la utility è un valore che ci dà, è una metrica che ci dà un'idea di quanto il dato sintetico sia simile al dato originale. Quello che vogliamo dipende dai contesti e ovviamente avere un'alta utility perché vogliamo che il nostro dato sintetico sia simile al dato originale. L'altro invece use case per cui può aver senso generare dati sintetici è il data sharing. Sostanzialmente può capitare che un'azienda, una compagnia ha bisogno di condividere i propri dati, magari per dei progetti di machine learning, perché non hanno dei team interni alla loro azienda. Però in questa condivisione dei dati ovviamente c'è di mezzo il problema della privacy dei dati. Spesso, se si tratta per esempio di banche o di ad esempio le poste, eccetera, i dati sensibili sono anche tanti all'interno di questi dataset. E con i dati sintetici, proprio perché si va a mantenere le caratteristiche del dato originale, ma allo stesso tempo si va a cambiare quello che è il dato originale, sostanzialmente non si riesce più a riavere le informazioni che sono presenti nel dato originale, si possono usare i dati sintetici. E in questo caso appunto la metrica, come vedevamo prima l'utility, in questo caso ci si focalizza sulla privacy. Appunto i dati sintetici possono essere utilizzati come tecnica di anonimizzazione del dato e rispetto ad altre tecniche più o meno complesse, i dati sintetici non sono un one-to-one mapping, cioè non c'è una mappatura uno a uno diciamo della riga del dato originale con una riga nel dato sintetico. È più un andare a prendere dei dati dalla distribuzione del dato originale e riportarli nel dato sintetico. In questo modo, se per esempio un hacker o qualcuno che vuole rubare i nostri dati personali, per esempio, conosce il tipo, nel senso, nei casi classici, se un hacker conosce il tipo di trasformazione che è stato fatto sul dato originale, la probabilità con cui riesce poi a risalire dal dato sintetico, dal dato diciamo anonimizzato più che sintetico, dal dato anonimizzato risalire poi al dato originale è maggiore rispetto a quando si utilizzano i dati sintetici, proprio perché non c'è questa corrispondenza. Quindi diciamo che quando generiamo dati sintetici il nostro obiettivo è quello di fare un trade-off, un bilanciamento tra le due metriche che abbiamo visto prima, quindi l'utility e la privacy. Dipende ovviamente dai contesti, perché se si tratta di uno use case più legato magari alla data augmentation, i dati sensibili saranno di meno, quindi magari ho più bisogno di un'alta utility, ma posso avere dei valori inferiori di privacy. Dipende appunto un po' dallo use case. Quando parliamo di anonimizzare i dati, ci sono diciamo due tipologie di identificatori che bisogna anonimizzare: gli identificatori diretti e gli identificatori indiretti. Gli identificatori diretti sono appunto nomi, cognomi, codice fiscali, quindi quegli identificatori che puntano a un singolo individuo in maniera univoca. E vengono anche chiamate in inglese personal identifiable information. Invece gli identificatori indiretti sono tutte quelle caratteristiche come l'altezza, il sesso, la città di nascita o il paese, la città di residenza, eccetera, che non sono per forza, non si riferiscono per forza a un singolo individuo, però se io ho queste informazioni su un singolo individuo e so che quell'individuo è all'interno magari di un dataset, posso risalire con facilità al dato originale. Con i dati sintetici ci si concentra soprattutto sul mantenere la privacy di questi identificatori indiretti. Per quanto riguarda gli identificatori diretti, diciamo, in alcuni casi si possono banalmente cancellare le colonne dal dataset con nomi, cognomi e tutti gli altri identificatori e non ho più quel tipo di informazioni. Il problema è che ci sono alcuni use case per cui si possono generare dati sintetici, come ad esempio il software testing. In quel caso è importante che la struttura anche del dataset e la semantica del dataset in sé sia mantenuta invariata, quindi non posso semplicemente andare a cancellare delle colonne, devo in un qualche modo andare ad anonimizzare i dati presenti in queste colonne, ma allo stesso tempo mantenerle. Quindi quando parliamo di identificatori diretti parliamo sostanzialmente di dati testuali però all'interno di dati strutturati. Queste sono alcune delle tecniche che si possono utilizzare per preservare la privacy sui dati testuali. Appunto si possono sostituire le personal identifiable information con dei generici placeholder, tipo il Mario Rossi italiano, John Doe è quello per l'inglese, oppure si può utilizzare la tokenizzazione, quindi vado a tokenizzare il testo, vado a identificare quelle che sono le informazioni sensibili e posso andare a inserire un token per sostituire appunto le informazioni personali, o infine posso utilizzare l'encryption o l'hashing. Tuttavia questo appunto è quello che si può fare sui dati testuali, però non all'interno di tabelle, o meglio, bisogna trovare un modo per fare questa cosa all'interno di dati strutturati. Ed è qui che entra in gioco NERPI, che è questa libreria appunto che abbiamo sviluppato. Il nome prende appunto, è la sigla di Name Entity Recognition for Personal Identifiable Information. La nostra idea era quella appunto di utilizzare questa tecnica di Natural Language Processing per riconoscere all'interno di un dataset le colonne dove vi erano degli identificatori diretti e poi andare a rigenerare dei valori randomici per appunto anonimizzare le informazioni personali. Questo perché appunto lavorando con le banche o con delle compagnie nel settore sanitario era importante mantenere la privacy di questi dati. Qui un breve riassunto su che cos'è la Name Entity Recognition. Appunto è una tecnica di NLP che va a identificare quelle che vengono chiamate le name entities, le entità nominate all'interno dei testi, possono essere persone, organizzazioni, date, eccetera. Adesso vedremo poi che modello abbiamo utilizzato per fare la Name Entity Recognition. NERPI è strutturata in due classi, c'è il Name Entity Recognizer, che appunto è la classe che performa la Name Entity Recognition sui dati strutturati, e poi c'è Faker Generator, che invece si occupa di generare le PI anonimizzate. Appunto il Name Entity Recognizer si basa e utilizza per la Name Entity Recognition diversi tool. Il primo è anche quello più, insomma, che si occupa della maggior parte del riconoscimento, è Presidio, che è un SDK di Microsoft, dove ci sono diversi tool che si possono utilizzare proprio per l'anonimizzazione dei dati, soprattutto dati testuali. Quindi il punto era sempre riuscire a lavorare con i dati strutturati nel nostro caso, e Presidio è particolarmente interessante perché è focalizzato proprio nell'andare a riconoscere quelle entità nominate che sono personal identifiable information, quindi nomi, codice fiscali, zip code, indirizzi, eccetera. Abbiamo poi utilizzato anche dei modelli disponibili su Hugging Face, sempre fine-tunati già fine-tunati per il compito di NER. L'abbiamo utilizzati sia per l'inglese che per l'italiano, che sono le due lingue attualmente supportate dalla libreria, e poi abbiamo fatto qualche processamento manuale basato sulle regex, che se qualcuno ieri era ad Advent of Code erano odiate, ma invece sono un ottimo strumento. Quindi questo è, la libreria si può installare con pip, ovviamente è open source, e questo è più o meno come andrebbe utilizzata. Si vede appunto che si possono dare come parametri il CSV e la lingua. Di default la lingua è l'inglese, però appunto si può anche mettere l'italiano. Ciò che si ottiene da questa prima fase è appunto questo dizionario dove abbiamo per ogni colonna un'entità nominata assegnata con uno score di confidenza. Ovviamente lì si può decidere se settare una threshold e decidere di assegnare l'entità nominata alla colonna in base alla threshold dello score di confidenza. L'altra classe invece della libreria è il Faker Generator, che si basa sulla libreria Faker, dove appunto ci sono una serie di provider per andare a rigenerare in maniera randomica delle informazioni personali. Faker ha anche tutte le puoi anche customizzarlo a diverse lingue, quindi anche in questo caso non solo la name entity recognition ma anche poi la generazione può essere fatta sia per l'italiano che per l'inglese. Questo è come va utilizzata, e quello che si ottiene è qualcosa del genere, ovvero si hanno le colonne, non tutte, perché per esempio company name è rimasta uguale perché non è stata identificata come una personal identifiable information, dovrebbe, però per lo stato attuale della libreria questa cosa non è fatta, però per il resto vediamo che il dato è anonimizzato, nel senso che ci sono tutta una serie di placeholder randomici. Diciamo che appunto ci sono ancora delle migliorie da apportare alla libreria, in primis il fatto di riuscire a adattarla anche ad altre lingue al di fuori dell'inglese e dell'italiano, e espandere il numero di entità nominate che vengono riconosciute dal recognizer e poi successivamente generate dal Faker Generator. E poi l'ultimo aspetto, ma forse il più importante di tutti, è proprio quello di riuscire a mantenere la coerenza tra le varie colonne. Torno un attimo indietro. Per esempio, in questo caso non c'è questo aspetto di coerenza, ci stiamo lavorando. Il fatto che l'idea sarebbe quella di generare un indirizzo che è davvero all'interno della città, la città all'interno del county, della provincia magari, e poi dello Stato. Allo stato attuale questa cosa è fatta la generazione è fatta per singola colonna, singolarmente. Stiamo lavorando appunto per cercare di mantenere questa coerenza. Anche lì dipende un po' dal caso d'uso. Ci sono dei casi d'uso in cui non è importante mantenere la coerenza quanto più avere delle informazioni simili, in altri invece questo aspetto di coerenza tra le colonne è fondamentale. Quindi sì, trovate NERPI a questo QR code e le slide all'altro, e grazie. Finito anche 10 minuti prima.
Grazie Simona. Ci sono delle domande che sono arrivate su Slido. Una di queste è: avete provato a fare fine tuning di un vostro modello NER?
In realtà no, perché sulle entità nominate, quindi però per entità nominate di dati sensibili è la domanda. Vabbè. Sì, immagino di sì. Allora, non l'abbiamo fatto, il problema è che per fare fine tuning comunque devi utilizzare dati sensibili se vuoi andare a riconoscere le entità nominate sensibili, e quindi c'è un po' il problema di non utilizzare dati personali, motivo per cui abbiamo deciso di utilizzare già dei modelli fine tunati, e Presidio fa questo, il modello NER di Presidio è esattamente fine tunato per fare questa cosa, quindi abbiamo utilizzato direttamente Presidio. Ok,
grazie. L'altra domanda era: come mai non usate Spicy, essendo più leggero che portarsi dietro le dipendenze dei transformers?
Ok, allora, Spacey per il modello NLP. Allora, Spacey in realtà all'interno di Presidio è utilizzato, volendo effettivamente le dipendenze dei transformer e il modello NLP. Allo stato attuale c'è, ma riconosce solo ed esclusivamente un'entità, che è quella delle organizzazioni, che adesso in Presidio non c'è. Potrebbe essere uno sviluppo futuro cercare di farlo anche in quel modo e velocizzare il tutto.
Ok. Grazie Simona.
Grazie.
Ok, direi che possiamo ripartire. Allora, ora Nicola Procopio ci parlerà di Don't Get Lost in Vector Space. Grazie Nicola.
Grazie Santino. Ciao a tutti, sì, ok, si sente. Niente, dai, siamo alla fine quasi, siamo un po' stanchi. Cerco di fare, diciamo, un breve tour sugli spazi vettoriali e sulle problematiche che abbiamo affrontato durante lo sviluppo del C-ShareCat, che è un framework di AI sviluppato in Italia, l'unico, il primo, alcuni mi hanno detto il migliore, visto che è l'unico, quindi vediamo un po' come affrontare queste problematiche, come gestirle, come superarle. Chi sono? Io sono Nicola Procopio e come lavoro, diciamo 9-18, sono Senior Data Scientist a Fincons Group. Poi tra le altre cose mi piace un sacco le communities, mi piace un sacco l'open source, quindi contribuisco ad alcuni progetti sia a livello, diciamo, open source codice sia nelle varie community, soprattutto, diciamo, in Calabria, ma poi diciamo anche nazionali e internazionali. Qui ci sono anche un po' dei miei contatti e dopo di questo iniziamo un po' a vedere che cos'è C-ShareCat, lo stregatto. C-ShareCat Production Ready AI Assistant Framework, ovvero un framework che permette di sviluppare sistemi di intelligenza artificiale basati su agenti e Retrieval Augmented Generation. Durante questo talk, visto che era stato etichettato, diciamo, come intermedio e ho più o meno 20-25 minuti, tante tecniche, tante nozioni base io le do per scontate. Poi, diciamo, su Retrieval Augmented Generation ce ne sono già stati tanti talk, quindi non ci torno su. Perché è production ready, come si dice qui, è ready to fight, quindi è tutto dockerizzato, un comando, avete Docker installato, un comando, parte il container e potete aprire l'admin e andare a giocare con il C-ShareCat, andare a sviluppare, provarlo. E poi model agnostic, non è legato a nessun vendor, ma vengono esposte API per modelli LLM ed embedder sia open source che privati. Se manca qualcosa, vedete c'è un plugin system and registry, potete sviluppare le vostre integrazioni, i vostri plugin mediante diciamo, questa funzionalità. Di base il C-ShareCat nasce con un core molto leggero e minimale, proprio perché nella RAG e comunque in questa nuova diciamo, frontiera dei framework per l'intelligenza artificiale non c'è uno standard, ogni task, ogni problema che andiamo ad affrontare è diverso, quindi noi diamo un software minimale, poi è l'utente che va a customizzare secondo come ha bisogno. Terzo, diciamo, ma non ultimo, perché focus del talk, è un sistema di RAG più agenti. Che cos'è un sistema di Retrieval Augmented Generation? Questo è quello vanilla del C-ShareCat, vedete, è proprio banale, entrano i documenti, chunk, cleaning, embedding, vengono caricati dentro il vector database, noi usiamo Quadrant, l'utente fa le domande, embedding, calcoliamo la distanza tramite similarità del coseno. Su questo faccio un attimo un breve passaggio. Noi usiamo la similarità del coseno perché, essendo model agnostic, non tutti i vettori calcolati dagli embedding sono normalizzati. Con la similarità del coseno noi possiamo anche andare a calcolare la distanza su vettori non normalizzati. Se avessimo avuto ad esempio solo vettori normalizzati, per essere più performanti bastava un dot product e andava bene così, però non è questo il caso. Poi una volta che abbiamo fatto la retrieve, i documenti vengono messi dentro il prompt, quindi il contesto del prompt, passano nel large language model e ci dà una risposta. Questa è proprio vanilla RAG, cioè base. In tutti questi passi potete mettere i vostri plugin. Ci sono plugin per fare parser, plugin per aggiungere metadati, integrazioni con modelli di embeddings, di embedder diversi, si possono andare a fare plugin per fare query con filtro su Quadrant, plugin per modificare la parte di user question tipo hide, che abbiamo visto anche ieri in un talk, l'avevano citato, la parte diciamo dopo che escono fuori le liste dei documenti dalla retrieve, quindi se volete fare dei re-ranking, oppure sul large language model andare a cambiare la personalità della gente. Magari il gatto ha una sua personalità, però volete un gatto cattivo e vi risponde male, e si cambia la personalità della gente e lui vi risponde male. Compatibilmente con diciamo, quello che fa fare OpenAI, non vi ci manda, ma se lo riuscite a jailbreakare o usate un modello magari open e volete, vi piace essere insultati, si può fare. Lì vi ho lasciato un link alla documentazione su come fare tutti i plugin. Perché abbiamo scelto Quadrant? Questo all'inizio, appena abbiamo scelto il DB, le diciamo, regole erano due. Deve essere open source e in piena filosofia Linux deve fare una cosa fatta bene. Quindi abbiamo scartato tutti quelli non open source, abbiamo scartato tutti quelli non dedicati ai vettori, tra quelli che vedete in quel quadrante abbiamo guardato i benchmark e Quadrant era quello che per noi perché noi abbiamo reputato il migliore, e quindi il nostro spazio vettoriale è costruito su Quadrant. Che cos'è uno spazio vettoriale? È uno spazio multidimensionale continuo dove tutti gli oggetti vengono rappresentati come dei vettori. Vedete nell'immagine c'è Homer Simpson, lui lì è 3D però è un vettore multidimensionale, c'è una sfera, ci sono delle lettere, ci sono dei numeri, c'è un cono, per chi ha visto questa puntata dei Simpson poi sapete anche dove va a finire, quindi sono tutti vettori. In quello che ci occupiamo noi adesso, quindi testo, viene anche detto spazio semantico, quindi embeddiamo parole, frasi, documenti. La dimensione dello spazio viene definita dal modello di embeddings, dall'embedder. Ad esempio, se noi usiamo ADA2 di OpenAI, il nostro spazio ha 1536 dimensioni. Cosa da dire subito? Lo spazio vettoriale va definito prima quante dimensioni ha. Come abbiamo costruito lo spazio vettoriale? Quindi diciamo punto 1, design del nostro spazio vettoriale. Nel Cheshire Cat lo spazio vettoriale prende spunto dalla psicologia. La long term memory, ovvero diciamo il database quadrant, è composto poi da 3 collection. Episodic memory, una memoria a breve termine dove noi memorizziamo le chat utente-agente. Declarative memory, memoria diciamo più a lungo termine dove ci stanno i documenti, quindi tutti i chunk che noi andiamo a caricare, e infine la memoria procedurale, dove ci stanno i tool. Su questa spendo giusto un secondo. Che cos'è un tool? È un pezzo di codice Python, una funzione che attiva l'agente in alcuni casi particolari. Esempio banale di tool, che è già integrato in Cheshire Cat, è il tool What Time Is It? Se voi chiedete che ora è a un LLM, l'LLM non vi sa rispondere. Se voi lo chiedete al Cheshire Cat, quando fa retrieve, prende il tool, che è impostato per attivarsi quando viene chiesto che ora è, il tool fa andare l'agente a prendere l'ora del container Docker e vi risponde che ora è. Quindi questo è il design della nostra memoria. Altra cosa che dovevamo scegliere è, le 3 memorie sono indipendenti, quindi ognuna ha il suo embedder, ognuna ha il suo diciamo, spazio vettoriale, oppure tutte in uno spazio. Abbiamo deciso tutte in uno spazio per andare a fare retrieve e poi per gestire meglio la parte con l'utente, perché 3 memorie, adesso sono 3, potrebbero essere 4, 5, con 5 embedder dovevo andare a embeddare 5 volte la stessa query per fare 5 retrieve diverse. La cosa diventava un po' più complessa e anche poco diciamo usabile, perché ci metteva parecchio. Come vi dicevo prima, lo spazio vettoriale va definito prima come dimensione, altrimenti poi si può incorrere in questa situazione, the drunken cat effect, l'effetto del gatto ubriaco, che è coniato da me medesimo e mi vanto di questa cosa. Cosa succede? Io ho settato, abbiamo detto, ADA2 come embedder all'inizio, quindi viene creata lo spazio vettoriale 1536 dimensioni, voglio cambiare embedder, ok? Prendo un embedder con uno spazio diverso, più piccolo, diciamo 512. Cosa devo fare? Niente, butto tutto quanto, ne creo uno nuovo a 512 e questo è il caso più semplice. Però voglio cambiare, uso text v3 small sempre di OpenAI, dimensione 1536, quindi lo spazio ha la stessa dimensione. Però cosa succede? Questa roba qua. Io qui ho due embedder, All Mini LM L6, All Mini LM L12, quindi stessa famiglia, diverso layer. Queste sono le frasi, sono le stesse, le codifico, vedete i punti rossi e blu, quelli rossi vengono sparsi più diversamente nello spazio rispetto a quelli blu che sono tutti concentrati. Questo perché ogni embedder ha la sua codifica, quindi anche se hanno la stessa dimensione, poi se io vado a dare una query e l'ultimo embedder è quello più sparso, codifica secondo quella query là, si trova in mezzo, non sappiamo quale sceglierà, e questo è un po' mixare gli embeddings, è un po' come per le persone mixare, diciamo, i cocktail, dopo un po' non ci capisce più niente, lui risponderà a casaccio, e da qui diciamo, l'effetto del gatto ubriaco. Come l'abbiamo risolta questa cosa qui? Mediante una feature di Quadrant che si chiama aliases. Gli aliases in Quadrant, potete guardare dalla documentazione, mi sono dimenticato di linkarla, serve soprattutto per una seconda label, per non andare a riscrivere tutto quanto quando magari passiamo delle collection da produzione, spostiamo, dobbiamo cambiare. Noi nel nostro caso invece lo usiamo come proprio seconda label della collezione. Quindi abbiamo le memorie dichiarativa, procedurale, e poi c'è una seconda label, questo alias, che è proprio l'embedder che noi andiamo ad usare. Perché non lo mettiamo nel nome? Perché altrimenti avrebbe avuto impatto su tantissime parti di codice e sarebbe diventato ingestibile. Invece il codice rimane sempre uguale e noi abbiamo soltanto questa etichetta che con un pezzettino di codice, questo qui sono i vari if che lo controllano, fa sì che io sono l'utente, ho scelto l'embedder, lo voglio cambiare. Ha la stessa dimensione? Sì, ok. L'alias che ho attualmente, diciamo, è ADA 2. Io ho messo text v3, quindi sono diversi i nomi. Sì, cosa faccio? Cancello tutte le collection, le butto via e creo un nuovo spazio. Questa cosa della cancellazione purtroppo è questa, cioè non si può fare altrimenti, tranne se abbiamo iniziato con questa sperimentazione, il dormouse, il ghiro. Tantissime funzioni prendono il nome da Alice nel Paese delle Meraviglie, quindi so così. Se si attiva il dormouse, quando io vado a cambiare embedder e prima di andare a cancellare lo spazio, fa uno snapshot Quadrant e ve lo scarica in locale. Poi la spiegherò alla fine questa funzione perché è abbastanza sperimentale, si può usare ma non è diciamo una feature core del gatto. Secondo problema, lo storage. Quando io immagino database vettoriali devono avere tanti punti, anche miliardi di punti. Questi vettori grandi hanno una impronta di memoria molto molto importante. Cosa si può fare per andare a ridurre questa impronta di memoria? Lì avevo lasciato anche un calcolo più o meno di come fare a stimarla, diciamo 4 bytes per numero di vettori per dimensioni dei vettori per 1.5, che è diciamo, una costante che mettono quelli di Quadrant, dicono anche per mettere un po' il calcolo dell'algoritmo, per indicizzazione, queste robe qui. Usare la quantizzazione. Quadrant ne offre 3, product, scalar e binary. Noi usiamo la scalar quantization. Perché non ne usiamo altre? La product abbiamo visto che non va bene per il nostro task a livello proprio di performance, invece la binary sarebbe molto più performante di scalar quantization, però dalle documentazioni Quadrant funziona benissimo con gli embedder di Cohere e OpenAI, visto che noi siamo agnostici non ci possiamo permettere questa cosa e quindi usiamo la scalar. Primo trick per andare a mantenere delle buone performance ma alleggerire è usare un modo ibrido. Si fa in Quadrant con una variabile booleana banale, quindi i vettori originali vanno salvati su disco, i quantizzati che sono più leggeri vanno in RAM. Che cos'è la scalar quantization? Convertire questi vettori, gli elementi di questi vettori da float a interi. Quindi da un range infinito di valori si passa a 256 elementi. La cosa importante è mediante quella formula lì. Quindi non è una troncatura, ma è una formula che volendo vi fa tornare al vettore originale. Una cosa importante è il quantile, perché serve per la calibrazione dei valori che poi escono fuori dalla quantizzazione. Scegliere il quantile viene consigliato di mettere da 0,95 a 0,99 perché quando noi andiamo a calibrare, a fare la quantizzazione, a noi servono quelle due variabili, offset e alfa, e quelle lì vengono calcolate mettendo a sistema quella funzione lì e dando a I8 ed F32 il massimo e il minimo del range di vettori. Se quello intero lo sappiamo perché magari vogliamo usare la codifica 0,255, quindi il minimo è 0 e il massimo è 255, di questo non lo sappiamo, e allora noi andiamo a prenderci il quantile e prendiamo il massimo e il minimo dei due quantili, tagliando fuori gli outlier per avere dei chunk migliori, più robusti. Nel caso dello stregatto noi usiamo 0,95, quindi togliamo fuori il 5% degli outlier dei valori. Che succede? Dice ok, va bene, adesso siamo più leggeri, ho lo storage, ma le performance, la qualità del dato è uguale? No, la qualità del dato perde un pochino, ma per mitigare questa cosa usiamo il terzo trick, che è oversampling e rescale. Io ho la query, ho i vettori quantizzati, faccio la similarità del coseno e voglio che mi torni 5 documenti. Non me ne faccio tornare 5, ma faccio oversampling. Per esempio, se ho un oversampling, un fattore moltiplicativo 1.5, lui me ne ridà 8 vettori quantizzati. Solo di questi 8 vettori quantizzati vado a prendermi l'originale, rifaccio il confronto con la similarità del coseno, mi darà un nuovo score, stavolta sono float, quindi mi dà un nuovo score, riordino secondo questo nuovo score e taglio i primi 5, me li tengo, gli ultimi 3 li butto. Sembra, diciamo, detta così a voce che fai più operazioni ed è più... però non è così, perché facendo questo lavoro abbassa di 4 volte l'impronta di memoria e aumenta di 2 volte le performance a livelli proprio di tempi. A livelli di qualità della risposta non si nota quasi per nulla il fatto che sia quantizzato o no, perché poi lì immaginiamo tantissimi punti, i punti sono densi, sono vicini, quindi più o meno quelli che doveva prendere prende lo stesso. Se poi abbiamo pochi punti quasi non servirebbe la quantizzazione. No. Ultimo trick, diciamo nuovo, i Matryoshka Embedder. Matryoshka Embedder sono, diciamo, Matryoshka Learning è diventato popolare con i nuovi embeddings di OpenAI, text V3, big, small e large. Cos'è una matrioska? Sono bambole innestate tutte uguali. Stessa cosa per gli embeddings. Sono embeddings, a volte anche molto grandi, che al loro interno hanno altri embeddings. Per spiegarvi il concetto facciamo un esempio tipo di Spotify, cioè, avete presente Spotify, il player? Ok, io vado sulla home e ho i generi musicali, pop, rock, questa è una caratterizzazione forte e quindi è come se fossero i primi elementi dell'embeddings, quindi dentro il vettore i primi elementi caratterizzano fortemente l'oggetto che è stato vettorizzato. Clicco su rock. Andrò più nel dettaglio, avrò delle compilation, rock italiano, rock anni 90, rock... sì. E quelli sono altri elementi dell'embedding che danno un po' di dettaglio. Clicco su rock italiano, mi escono, non so, cantanti, band. Quelli sono altri elementi dell'embedding che danno un ulteriore dettaglio, ok? Scelgo una band, ok, siamo a Firenze, scegliamo, io voglio ascoltare Litfiba oggi. Bene, quindi ho questi elementi qua. Mi si aprono tutti gli album, diciamo che i Litfiba più o meno hanno nella loro storia 3 periodi, trilogia del potere, tetralogia degli elementi e poi la reunion. Quello è proprio il dettaglio, sarebbero le sfumature semantiche in una frase, tipo l'ironia, così. E quelli sono gli ultimi elementi del vettore, quindi se il vostro task, al vostro task serve cogliere queste sfumature di linguaggio, prendete il vettore più grande. Se no, potete provare a stringere il vettore fino a quando voi arrivate a un punto che magari per il vostro task serve solo la caratterizzazione di quel vettore, del tipo polarizzazione, positivo o negativo, e quindi io prendo la bambola, la matrioska più piccola, i primi 120 elementi di un embedding che magari poteva avere 8000 elementi della sua versione più grande, e questo vi fa risparmiare memoria e vi fa risparmiare tempo, perché comunque moltiplicare vettori da 8000 elementi e da 125 è una bella differenza. Ultima cosa, per non perderci nello spazio vettoriale, è avere una mappa. Spazio vettoriale, abbiamo detto, è ad altissime dimensioni, 126, 1530, 8000 e passa con gli embeddings tipo di Gina AI. Cosa andiamo a fare? Usiamo un algoritmo di dimensionality reduction, tipo TSNI, per avere una proiezione 2D del nostro spazio. E qui possiamo fare ricerca dalla barra e farci tornare 100 punti. Una cosa su cui ci tengo a dire di questa cosa qui è di fare attenzione, perché noi questa è una proiezione di uno spazio multidimensionale su un 2D. In più, le distanze che abbiamo calcolato sono distanze del coseno, invece, diciamo proprio a livello umano, a noi ci viene a colpo d'occhio di andare a vedere le distanze euclidee sul piano. Quindi una cosa, un bug che ci viene segnalato spesso, magari anche nelle chat, dice ma io metto la query, mi dice che è quello che è più vicino a uno score più basso, perché quella dovrebbe essere una similità del coseno su magari 1536 dimensioni. Questa è una proiezione. In più, pur volendo calcolare la similarità del coseno, non ce la facciamo perché è una porzione di spazio, noi non vediamo l'origine per fare l'angolo. E quindi questa cosa qui bisogna fare attenzione, e succede soprattutto quando viene aperta questa maschera di detail, dove noi abbiamo effettivamente tutti i documenti e anche qui in nero, non so se si vede, lo score rispetto alla mia query che era "Do you like Eric Clapton?" E il primo documento, quello più in alto, è "Sing to me John Lee Hooker Song", perché io gli avevo chiesto di scrivermi una canzone con lo stile di John Lee Hooker, quindi quella è una chat che viene dalla memoria episodica, infatti è segnalata la episodica. Non avevo documenti su Clapton. In più, da questa maschera qui si possono cancellare anche tutti i punti delle memorie, oppure una memoria sola. Se magari volete fare dei test, fate come ho fatto io qui la chat, però dice io non voglio cancellare tutte e tre le memorie perché io ho caricato dei documenti, ho fatto dei tool, voglio cancellare solo la chat che ho fatto con lui, cancello solo la episodica con wipe lì in alto. E ultimo, ma non meno importante, come non perdere i documenti. La cosa più semplice da fare è o esportarli da quella maschera che vi ho fatto vedere prima dove c'è anche la mappa, oppure entrare proprio nella cartella del C-Share-Cat, c'è una cartellina long term memory, ci sono dei JSON, sono dove ci stanno i vettori, ve li prendete e li portate da un'altra parte, li potete anche condividere e caricare su un'altra istanza di C-Share-Cat. Oppure, un pochino più pesante, più complessa, è questa cosa qui di svegliare il ghiro, perché dovreste andare nel file di environment, mettere a true una variabile d'ambiente, e quando voi fate questa cosa lui si fa gli snapshot, diventa più lento il meccanismo. In più non c'è ancora la funzione di importare questi snapshot, perché lo snapshot sono soltanto i vettori e il nome della collection, non si porta gli alias, quindi poi lì andrebbe, diciamo, a spaccare tutto, perché quando va a fare i confronti non ce l'ha. Stiamo facendo delle prove per vedere se si può fare un update di queste collection importate mettendo gli alias di volta in volta, però è una cosa sperimentale e al momento è in work in progress. Beh, io diciamo, spero di aver detto tutto, che non, diciamo, la stanchezza non mi abbia ingannato. Se ci sono domande, penso che abbiamo ancora tempo. Poi vorrei ringraziare tutti voi. Prima diciamo, delle domande volevo fare solo un ringraziamento. Mi piacerebbe facesse un applauso a qui c'è Santino, sono tutti i ragazzi con la maglietta gialla, perché ogni anno sono volontari e fanno sempre una bella festa. Okay. E questi sono tutti i contatti del progetto, ci trovate un po' ovunque. Grazie.
Sì.
Le slide stanno già sul mio GitHub, però penso che nel pomeriggio cerco di condividerle sia sul Discord del PyCon che su LinkedIn, tanto so in treno 6 ore, qualcosa dovrò fare.
Grazie Nicola. Se ci sono anche delle domande, diciamo, live che volete fare, vi cedo il microfono.
Allora, o sono stanchi o non si è capito niente, che è la cosa che io credo.
O si è capito tutto?
O se,
Va bene.
O pensavano che fosse un talk su C-Share-Cat e sono rimasti fregati perché doveva venire Piero per fare quella cosa lì. Se avete domande sul gatto, diciamo, visto che c'è tempo, vi rispondo per quel che so, perché io mi sono occupato solo di una parte, non so proprio, diciamo, tout court.
C'è modo di intervenire sulla classificazione dei documenti o sullo spezzettamento in chunks dei documenti?
Sì, allora ci sono già c'è un plugin che dovrei prendere un'altra presentazione, però devo cercare. C'è un plugin che si chiama CAT, proprio CAT puntato, che è C-Share-Cat Advanced Tool. Scaricando solo quello tu puoi intervenire sul prompt dell'agente, quindi sulla sua, diciamo, personalità, puoi intervenire su quante documenti viene fatta la retrieve, puoi intervenire sui token per fare il chunk e l'overlap. Non ricordo se ci sono comunque sono tutte queste configurazioni, diciamo, base. Io consiglio, quando viene installato la prima volta, questo plugin di installarlo subito perché è molto comodo. Poi, prima che mi facciano questa domanda perché va di moda, sì, il Semantic Chunker c'è, è un plugin, però è già sperimentale in LangChain perché il C-Share-Cat sotto a LangChain. Abbiamo fatto questo plugin, funziona per problemi di tipi tra LangChain, Pydantic, queste cose qua, vi darà un errore, ma se voi lo avviate da Docker, chiudete il terminale e lo usate normale, non vi accorgete di niente, perché funzionare funziona. Sì, comunque sì, ci sono tantissime customizzazioni, c'è la barra dei plugin, adesso io qui l'ho messo soltanto alla fine, però se guardate lì c'è home, che poi dove sta la chat, memory, sono queste cose, queste schermate che ho fatto vedere io, plugin è una lista molto simile al Play Store, l'App Store, dove ci sono tutti i plugin che vengono sottomessi e accettati dal team di C-Share-Cat. La maggior parte sono fatti da volontari, qualcuno è fatto anche da qualche azienda. Poi ci sono i settings, dove si possono scegliere gli LLM e gli embedder da utilizzare, e alla fine Docs vi porta alla documentazione. Io quello che vi consiglio è di consultare la documentazione, di andare a vedere anche, prendiamo di nuovo qui, sia su C-Share-Cat AI c'è un blog, ma anche su Medium, la newsletter, perché lì scriviamo un sacco di tutorial, quindi la maggior parte delle cose, diciamo, base le abbiamo coperte. Se poi avete delle esigenze ci possiamo sentire su Discord, se poi le risolvete e ci scrivete un tutorial, a noi fa piacere.
Ultima domanda, c'è modo di disattivare la memoria storica, cioè delle richieste fatte dagli utenti nella stessa conversazione, in maniera programmatica?
In che senso?
Nel senso che non appena io faccio le prime domande in chat, che ho provato,
Sì.
che C-Cat è
Sì.
un fantastico strumento, dopodiché quando faccio altre domande simili è probabile che anziché andare a pescare nella memoria dichiarativa posso andare a...
Puoi
prendo
usare
quella storica.
questa cosa qua, il wipe. Vedi, tu fai wipe
No, intendo in maniera, cioè disattivare cioè
e devi fare un plugin.
Ok, col plugin si può fare.
Col plugin, sì. Mi pare che si chiami Look, che lo va a toccare after the cat recall memory, dove
Ok.
ci sono le 3 liste e tu dal plugin gli dici che quella episodica non la deve prendere. Oppure quella episodica rimane sempre vuota, cioè gli metti una lista vuota invece della chat ogni volta.
Grazie, perfetto.
Sono 2 soluzioni, diciamo, non ottimizzate che mi sono venute in mente.
Io ti volevo chiedere se hai dei suggerimenti per buone pratiche sulla dimensione dei singoli documenti. Cioè, immaginiamo che io ho una knowledge base interna aziendale e io posso scegliere, no? Se spezzettare in tanti piccoli documenti o avere delle grosse sezioni.
Allora, su questa cosa qua, come dicono tutti, anche i grandissimi della cosa, it depends. Questa citazione. Comunque ti posso dire che sarebbe meglio avere dei chunk un po' più piccoli. È naturale che se tu li hai molto molto piccoli e magari il tuo task richiede dei chunk più grossi, non trova niente. Se tu invece metti un chunk molto grande, naturalmente l'embedder crea sempre un vettore della stessa dimensione, quindi o te lo tronca perché hai più token, lui in ingresso arriva a un certo numero di token, quindi su questa cosa no, stanno registrando, non la posso dire, dico. Però diciamo tu il tronca è arrivato a un certo punto e il vettore rimane sempre molto generico. perché è un documento molto grande. Una cosa che ho provato e che funziona, ma su un task molto particolare, è il multiple chunking. In pratica io, però questa è una cosa che vado a fare perché in questo task non ho tantissimi documenti che vengono caricati in continuazione, sono diciamo dei contratti e so quelli, non sono tanti, praticamente per ogni paragrafo che io vado a caricare lo splitto in diverse numerosità di chunk e diversi overlap. E in più nei metadati gli vado a mettere però l'originale, quindi io la retrieve lo faccio sugli split, poi controllo se l'id del documento originale, del paragrafo originale è uguale, mi prendo soltanto quello che ha lo score più alto, però poi nella... aspetta, dove è andata? Qui nella parte di enriched question, quindi quando vai a passare il contesto dentro il prompt per l'LLM, io non gli do il mio chunk che ho fatto retrieve, ma gli do il testo originale. E lì quello serve perché a seconda di che embedderai potresti avere, di che domanda gli fai, potresti avere un risultato migliore con un chunk più piccolo e più grande. Visto che io non lo so e in questo task non è che io vado a scrivere le domande, è tutto programmatico, è tutto buildato e si fa tutto in automatico, lui deve avere tutti i casi e allora abbiamo usato questa situazione che non è ottimizzata per una RAG classica, è proprio una cosa ad hoc per questo tipo di task. Infatti, come avevo detto, dipende da quello che vai a fare. E quello che ti posso consigliare è di magari caricare pochi documenti con chunk più piccoli, fai 2 o 3 prove e allarghi, non andare mai sopra il chunk da 700 e qualcosa, perché poi comunque gli embedding, anche se dicono che si sintetizzano con milioni di token, però poi il documento è troppo generico e quindi il vettore di per sé è un mischione e te li mette tutti sparsi lì nello spazio, non si capisce, non è caratterizzato uno, non è caratterizzato un altro. A meno che non metti nello
Chiaro,
stesso
grazie.
spazio, non so, il manuale del motore della macchina e il libro di cucina, lì sì, però
C'è posto per l'ultima?
certo.
Ciao, io mi chiedevo se c'era un concetto di utente nella memoria, nel senso ipotizzare che magari una memoria su documenti possa essere condivisa tra diversi utenti, poi quella singola naturalmente lasciata.
Allora, questa cosa qui è stata richiesta nel Discord, ne abbiamo parlato, non è stata fatta non per problemi diciamo tecnici, non è stata fatta perché come detto noi il GAT, cioè C-Share rimane basic. Ci sono delle persone che hanno fatto il plugin, delle aziende che lo hanno fatto, però giustamente essendo un plugin diciamo aziendale loro, delle sessioni, login con single sign-on e cose varie messo sopra, non l'hanno condiviso. Però sì, si può fare, diciamo se tu hai questa necessità, con un plugin ci puoi mettere l'utente, ci puoi mettere la sessione e c'è già. Quindi gli utenti, tipo la login, queste robe qua. Non è stata implementata perché sennò se vai a fare la demo magari ho, non so, gli install party, queste cose qua e si devono loggare 200 persone, è un casino. Il vector DB, allora, Quadrant ha diversi tipi di installazione, perché per esempio già noi ne usiamo 3 o 4. Per fare le demo c'è quello a file, c'è quello in memoria locale che puoi mettere sui server. Penso che se tu lo metti in memoria sui tuoi server, poi lì vai a gestire gli utenti, oppure se usi il Quadrant Cloud, lì c'è l'utenza. Per esempio io ho iniziato con Quadrant come diciamo early adopter, ho fatto la mail, mi hanno dato il nodo sul cloud, penso che lo facciano ancora, quindi se volete provare vi consiglio ti danno un nodo e un token e tu ti loghi sul tuo Quadrant, sul tuo nodo e ci fai le tue cose. Quindi sì, di base lui ce l'ha, non c'è sul C-Share Cat, perché questo come detto va fatto con i plugin a seconda delle necessità utente.
Grazie.
Grazie a voi.
Oh, hello, hello. Wow. I was going to say, will it work automatically? Yes, it will.
Okay, so now we start with a new session with Karen Jackson that she talks about how optimizing your database for analytics. Thank you, Karen.
Hi, thank you. So I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and it is a huge pleasure to be here at my second PyCon Italia, this time talking to you about how to optimize your database for analytics. And we've already established that some people in the room other than me actually like databases, which is really cool. First of all, I always have to get the confession out of the way. I'm not a developer, I'm sorry. But as you can see from this diagram of my career so far, I do know about databases. I've worked with databases for 25 years now. I was a DBA for about 20 years, and I was once described as quite personable for a DBA, so make of that what you will. And I'm currently a senior solutions architect, but I still only work with databases. So I've worked with loads of developers along the way, and I still work with developers, and I've learned loads from them. I love going to the different talks at the PyCons, and I try to give back some of what I know about databases. Okay, so what am I actually going to talk about today? To try and help answer that question, I'm going to talk about some of the different kinds of workload that you might be running against your database. In all my diagrams, you will notice that I am very much a database person. I've conveniently missed out the whole application layer. So please forgive me for that. This is my vision of the world. We have the database, and we have kind of everything else that goes on outside of it. Okay, so you probably have an application, or maybe many applications, that has a back-end database, or databases. And the database is probably constantly being queried, updated, inserted into by your application users. So it could be a traditional payroll or banking app, it could be online commerce, it could be one of all sorts of different applications. And that typical traditional database activity is what we usually hear called OLTP, or online transaction processing, or sometimes your operational database activity. So that kind of workload is characterized by lots of concurrent connections, so lots of concurrent users, and those users will be usually performing short statements, so they'll be doing quick selects, inserts of just a single row, for example, and they'll be doing multiple of those statements per transaction. So that's what we think of when we describe an OLTP workload. Most of this type of application will then gradually build up data over time. And a lot of them don't actually have a strategy for purging old data, but that's a different story. And at some point, the business wants to make money from, or rather glean insights from, this data. And that means you're going to need to run analytics queries. So analytics workload can take many different forms, and it's got lots of different names, so sometimes known as OLAP, online analytical processing, reporting, decision support, DS, business intelligence, BI, and it's basically any activity that serves to answer real-world business questions. So it might be something like, how successful was our last marketing campaign? What's the impact on our CO2 emissions of performing this action compared to this one? Or how much extra coffee do we need to order for PyCon Italia next year? So this OLAP type activity is characterized by much longer, more complex queries. So it will typically be select activity. It won't be updating your database. You'll be potentially joining data from multiple tables and working on large data sets, which means often it's very resource intensive. Once upon a time, we had the OLTP databases, and we had the analytics or OLAP databases, and the two were very much separate. Data would somehow be extracted from the OLTP systems, and imported, inserted somehow into the OLAP system. That could be by an overnight batch process, or sometimes even a weekly roll-up of all that data that then got imported. And that does sometimes still happen, and there are some very good reasons for still doing things that way, but often the business doesn't want to wait overnight or until the next week for that data. It wants to get real-time information, real-time value and insights from the OLTP system. So that means often directly querying those systems. So wherever you've got this OLTP plus OLAP in the same database, you'll hear that called either a mixed or a hybrid workload, and that's the kind of thing that we're going to be talking about today. And it's not a new idea. So Gartner came up with the term HTAP, Hybrid Transactional Analytical Programming, back in around 2010. And it's been described in other places as translytical, or I've seen HOAP, Hybrid Operation and Analytical Processing. So what's the problem with this? It's well established in academic circles that this type of workload presents unique performance challenges. So I've seen papers from 2010, 2011, where researchers identified the fact that running mixed workloads can cause performance issues, and then there are ongoing discussions about the best types of benchmarking, et cetera, to look into the performance of this type of workload. But you'll be really pleased to know, I imagine, that I'm not planning an academic discussion. I want to just focus on the actual practicalities of what you can do if you're in this situation where you've got a mixed workload, how you can make sure you've got performance analytic queries and not have an impact on your day-to-day database workload. So just to recap, chances are your database is optimized for your day-to-day OLTP activity. So lots of short selects, inserts, updates, deletes, potentially deletes, run by multiple concurrent users. Once you add analytics activity into the mix, you've now added on some much more complex queries, long-running queries that are resource-intensive and working on big data sets. So that means you can actually end up with inefficient analytics queries and an impact on your existing database activity. Okay, so we've identified the problem that we're trying to solve. Next, we need to set up an environment so that we can test things out, try things out as we go along. I'm using Postgres for this because that's the RDBMS that I work with day to day, the one that I know and love. And also, it's very quick and easy to set up and work with to test things out. And I'm going to be using pgbench, which is a really simple benchmarking tool that's available by default with PostgreSQL. And I'll show you how that works. So first of all, you initialize pgbench. I am very old school. I do everything on the command line. I apologize for that. Actually, no, I don't apologize. I like it. So I've initialized it in a database that I created called PyCon Italia. The -i flag is what does the initialization, and it's creating me some test tables that it's then going to run the transaction against. I've set a scale factor -s of 100, and I've asked it to create foreign keys between the table just so that it looks a bit like an actual application setup. Okay. So this is what it creates for me. It creates me 4 tables. So I've got my pgbench branches, accounts, tellers, and history tables. These numbers of rows here are the initial number of rows that it will create in those tables with a scale factor of 1. So we've got 100 times that number of rows. The pgbench history table will start out with 0 rows at the beginning of each pgbench run. Okay, so that's it set up. We've got the tables created and we've got some data in there. And this is the activity that it runs by default. You can set it to run any script of your choice. You can actually create your own tables if you want to, but for most demo purposes, or if you just want to try out a few little things, the defaults are great. So it repeatedly runs this transaction, which comprises of 5, I think, if I've counted correctly, short statements, which is based loosely on the TCP/B benchmark, if you're familiar with that at all. And it takes random values of AID, TID, BID, and delta for each of the transactions. So when you want to actually simulate some activity on your database, you run pgbench without the -i. So this time I'm telling it to run for minus T60 tells it to run for 60 seconds. The minus C10 is telling it to run with 10 concurrent clients. This is all running on my MacBook, so you know, I don't want to set it up running with too many concurrent connections just in case I fall it over. But in this case, I'm getting 5,000 transactions per second. So the goal here isn't to get the best performance, it's just to run something so I can see different impacts on the things that I do. And then I've mocked up an analytics query to look a little bit like an annual sales report. Now, those of you that actually do analytics will notice that this is an extremely simple query. It's good enough for demo purposes. This would probably be just one building block of a bigger analytics query. But you know, for running on my database on my Mac, it's absolutely fine. So before testing anything with my analytics query, I let pgbench run for 20 minutes to generate some data in my pgbench history table, and that gave me about 15 million rows. So we're running this. We're still going to call it an analytics query. We're running this analytics query against about 15 million rows in the database. Okay, so let's have a look at the execution plan for this. So I don't know how many people here are familiar with PSQL. It's the PostgreSQL command line tool. If I say explain, I'll wait for it to come back around. If I say explain analyze, and then my statement, the analyze part tells it to actually run the command, and the explain bit tells it to show me the execution plan, tell me what you've actually done to get the results. So you'll get the actual results rather than an estimation. I apologize, I should have left that to stay on for longer. But what you'll see here is that it's doing some, what it calls external merge sorts, so it's doing some activity on disk. It's taking just over 8 seconds to complete. So there are the external merges on disk, and we can see that it's doing a sequential scan on pgbench history, so it's got to read the whole of that table. Just in comparison, the select statement in that pgbench transaction takes approximately a millisecond to run. Okay, so now we've got the environment in place. Let's have a look at some of the different things that you can do to optimize that analytics type activity, but without having too much of an impact, or any impact preferably, on your day-to-day application. This is definitely not going to be an exhaustive list of all the things you can do. It's not a full performance tuning exercise, even of just that one query, but the idea is to give you an idea of the different areas that you can look at so that you can try things out and see how they go. Again, I'm using Postgres. The details here will be specific to Postgres, but the general ideas are relevant for any relational database system. So I mentioned before, your database is hopefully tuned for your day-to-day activity. So hopefully your database configuration parameters have been carefully considered and set accordingly. If not, I highly recommend having a look at them. And that gives me an excuse for a shameless plug. So this is a talk that I did on that exact subject at DjangoCon EU last year. So they're all about how to set your different Postgres configuration parameters. Okay, so some parameters need to be set across the whole of your database instance. Some parameters can be set for individual users or individual sessions. Some can even be set for individual statements. The ones that have to be set across your whole Postgres instance, you're going to have to find some kind of compromise that works for your OLTP activity and your analytics activity. So that part there can be a bit of a challenge. So I'm just going to talk about a few of the parameters, and I'm going to encourage you to go away and read the docs. The Postgres docs, they're actually not that bad. They're, quite descriptive. It has a full list of all the different parameters, what they do, what the default values are, etc. So you could have a look at that. Firstly, your database connections. So the chances are you won't have all that many concurrent analytics sessions, but they are going to be resource intensive. So you probably want to keep an eye on them and make sure there aren't too many of them. You've got the max connections parameter in Postgres, but it's for the entire Postgres instance. By default, it's set to 100, and usually you don't want to set it much higher than that. It's a few hundred max in general for a Postgres instance. But on the other hand, that's not going to be all that useful to you potentially for making sure you don't have too much analytics activity going on in your database. So what might be more useful is to put connection pooling in place. You can have a separate, smaller pool of connections for your analytics activity so that you restrict the number of analytics connections that you can have whilst leaving more connections available for your day-to-day application activity. Work mem. This one says how much memory a query operation or a sort operation can use before it spills to disk and creates a temporary table. So we saw in that execution plan before that we had some files created on disk. It was doing some sorts on disk. So work mem is what impacts when that happens. So the higher work mem, the less chance you'll have of actually going onto disk and doing your work on disk. So complex queries that perform lots of different sort operations will usually benefit from a higher value of work mem. Just be aware, if you set that across the whole instance, so it's 4 meg by default, if you set that to 100 meg or more across the whole instance, if you've got 50 users all running a couple of queries that maybe are using, 2 or 3 lots of work mem, that's going to quickly build up into gigabytes of memory across your database. So a better way to do that would usually be to set it for individual statements. You can use this parameter here, set log temp files 0. If you do that, you will see in your Postgres logs every time it creates a temp file. So every time it creates one of these files on disk, if you see that happening lots, then it gives you an idea that at least some of your statements need more work mem. And for any parameter or Postgres functionality that I talk about, I've put the link to the documentation in there. And I have got a link to the slides at the end. Okay, so I tested out the analytics query with different values of work mem. So we could see it was 4 meg to start with. I tried it with 100 meg. This, when I do set, that's just setting it for this statement. Okay, so that one, I can see I still had an external merge on disk, and it was still taking just over 8 seconds. Then I set it to a gigabyte just to see what that did, and I can see it's doing it all in memory now. It's doing what it calls a quick sort, but it only took it down to about 6 seconds, which doesn't seem to me like a huge performance increase for the sake of using a whole gigabyte of memory just for that one small query. So obviously that's going to vary from case to case. It's worth testing out for your particular queries what the best value of that parameter is. Statement timeout. So if you're concerned that you're going to have analytics queries that are going to run away, that are going to run for too long and therefore cause performance issues on your database, you could set statement timeout, which will abort any statement that runs for longer than a given amount of time. It's disabled by default, so statements can run for as long as they want to. You can set it for the entire Postgres instance if you want to, but it's probably better to do it for individual sessions or groups of sessions. So, for example, your normal application activity might be allowed to have statements that run for milliseconds or seconds, whereas you might have analytics queries that are allowed to run for many minutes. Okay, so just to demonstrate that, I've tried setting the statement timeout here. So have a look at what it is to start with. It was 0. I set it to 2 seconds. And then I tried rerunning that analytics query just to confirm that that's actually working. And there I can see it cancelled it. So it's cancelled it there, just over 2 seconds. So cancelling statement due to statement timeout. If you want to know when that's happened, you can make sure that logmin error statement is set to the right value. So that will make sure that any statement that's aborted in that way is written to your Postgres logs so that you can keep track of that. So here are the possible values of that parameter. By default, it's set to error, which means that anything error and above will be logged in the Postgres logs. So yeah, whichever value you set it to, it will log that and above. So if you don't want to see anything to do with this, then set it to panic and you won't see these errors logged. Okay. Indexing strategy. You will probably need specific indexes for these analytics queries. The main thing to be aware of is that indexes need to be maintained. It's not, as well as the space that's needed for an index, it impacts the performance of your updates. So that index has to be kept up to date. So you don't want to be adding too many indexes. You want just the ones that are actually really going to help with your queries. A really useful tool can be the indexes on expressions. So you might, for example, in our analytics query, we'll have a look. We've not just selected a column, we've selected an expression based, a value that's based on an expression on that column. So here I've tried out again, creating an expression-based index. So here I've created the index on my PG Bench history table, and instead of creating it on the mtime column, I'm creating it on those 2 columns that I've calculated. Okay, so now we can see that it's using that index. It's taken our execution time down to kind of 5.5 seconds, and we've not got any of those disk scans. Don't forget that each of these things that I'm doing is just one thing. You can put multiple of these together to figure out what works best. And we've just got one query that we're looking at. Obviously, in the real world, you're going to have multiple analytics queries, so it's always going to be a balancing act trying to get the right thing for each of those. Okay, the most performant way of doing something is usually to not do it. So we can pre-calculate, pre-sort, pre-aggregate some of that data that's needed in our analytics queries so that we just do it once. We don't have to keep doing that each time we run our analytics queries. One of the ways we can do that is using stored generated columns. So if I use this generated always as, that's effectively setting a default value for a column in my table. But if I specify stored, that's actually going to calculate it. So when I insert into my test table just the values A and B, it's going to not only calculate that at runtime, sorry, it won't calculate it at runtime, it will insert it physically into the table when I do that insert. So I've now got that calculated value in my table. When I run an analytics query looking for A plus B, I don't have to calculate it each time, it's already calculated for me. Obviously, that's going to have an impact on your insert, so you need to balance that out. Okay, so I'm going to leave out some of these demos just to move on. So I did that in the PG Bench history table, and it cut my execution time down to 3 seconds. So that was quite cool. Materialized views are another really good way that you can pre-aggregate and pre-sort your data. So a materialized view is a physical copy of the results of a query. So I said before that that analytics query that we're doing could be just one building block in a bigger query. So we can create a materialized view of that query, so that then whenever we want that block in our query, we don't have to go to those base tables and calculate everything. We can just select it directly from that materialized view where it's already been calculated, aggregated, and sorted. And when I did this, it actually took the execution time down to 2 seconds because we're just looking in the pre-calculated materialized view. And then the final thing really is that the best way to avoid impacting your application database is really not to run these analytics queries against your against your application database. So even if you don't have a completely separate analytics system, there might well be options available to you. You've probably already got a high availability solution in place, so you've got one or more standby databases where the database is being replicated to. You could run your queries against that. Disadvantages are that you can't make any changes there. You'd have to still make those changes against the primary database, so you're still having some impact, but at least the actual queries are running against a different database. So those are the advantages and disadvantages that I mentioned there. But you also have logical replication, where you can have a publisher database and a subscriber database. You can send just some objects, just some tables, to a standby, and you can even have multiple publishers sending to a single subscriber, multiple publishers sending off to multiple subscribers. So you can configure your analytics environment the way you want using that. Obviously, you need the space for all of those extra databases if you do that. But the advantage is, oh, and this is just a Postgres 16 thing saying that you can do that from your standby database now. So you have a lot more flexibility. It's more difficult to put in place, but you have flexibility. You can create extra indexes on that standby database. You can create your materialized views there. You can create those calculated columns so that you're not having an impact on your primary application database. And then, I don't have time for this, but this is a kind of fun thing that the folks at Crunchy Data have been working on, which doesn't solve this particular problem, but I think it's really cool. So I've just put a little link in there. So it's running analytics from your Postgres database. So it's just available with the managed service at the moment. So you run it from your Postgres database using Postgres syntax, and it's got a vectorized query engine that will then let you query things in object storage. So it's quite fun. So you can go and give that a try if you want to. So that was the summary. The best way, if you can, is separate analytics databases, but that's not available to everyone. If not, look at your configuration parameters, your indexing strategy, and see what you can do to pre-calculate and pre-aggregate your data. So hopefully that's given you some useful information and enough of a starting point to go away and have a look at the different things that you can do yourself. Thank you very much.
Thank you. We have the space for the timing for only 2 questions. Sorry for you.
Sorry, and I don't want to stand between people and their lunch either.
Yes. One was, what is your experience of database performance on SSD versus, against, imagine, managed cloud database with much lower IOPs but higher concurrency?
So against?
What is your experience of database performance on SSD hard disk, imagine?
Yeah. So I don't know anybody now who's not running their databases on SSD storage.
Okay.
Yeah, precisely because it's cheap enough now that people don't need to worry about that side of things, and it is so much better. Yeah.
Okay, and the last was removing the index to big DB is a heavy operation. Did you have a situation when you had the index to run some analytics and delete it afterwards?
So that's where you really want to be able to have that, for example, that logically replicated
Yes.
data, because then you can create those indexes without having an impact on your primary database. That's probably the ideal in that case. Yeah.
Thank you.
Thank you very much.
Sorry for my English, it's not clear.
No, not at all. No, it's me.
Sì, ma l'ha presentato anche a Good Motion, Lele, no?
Vabbè,
Va bene,
okay.
un applauso alla regia.
So, we have some changements of our schedule, but our community is always ready to solve problems. So we have Luca Biaggi on the stage. He's in Python Milano,
Yes.
the one of the community manager of Python Milano, and he's an international speaker. And he's here now to talk about.
Three keys idea to understand ChatGPT, namely embedding transformers and reinforcement learning for human feedback.
So please welcome Luca on the stage.
Here. So thank you, Michela. Hello there. So this talk is actually a portmanteau, actually a reinterpretation of one that my manager did, Emanuele. Emanuele is a wonderful divulgator. People going around and talking about stuff. I'm pretty sure you might have encountered him already if you were snooping around in Italy or, so for example, recently PyData Berlin. And he originally made the talk, so most of it, like 99% of the credit goes to him. And he has a really fun way to start talking about ChatGPT, right? Because our work, my day-to-day job is in the same company as his, which is called Extreme. We do AI solution and consultancy, and we really do care about going around trying to explain people what AI is and what it means, right? And before ChatGPT came out, it was fairly sometimes tough, right, to give people an understanding of how relevant and everywhere AI was and is. We were going about like talking and say, okay, guys, right, use Instagram, right? You know that the recommender algorithm, there's an algorithm behind that builds like and suggests you the content afterwards that is tailored to you, and that's because that's an algorithm, right? Now it's just easy. It's much, much easier, right, to go around and say, where is AI? For example, how many of you have at least used once ChatGPT, right? Basically everybody, right? Rendering the introduction to this talk mostly useless. But there is another thing to say. You know what ChatGPT is? It's just an AI. It's the most popular product ever. And it's by far the product that took the least amount of time to get to 100 million users. And this is remarkable, but there's also, and we need to really like to get a feel for how persistent it will be, and it actually is in our lives. And it's going to become even more and more, right? It's going to become more and more relevant and prevalent in our lives. We need to understand the three key pieces that make it work as such. So we're going to talk about, right, and to start understanding properly, we talk about these three key ideas: embeddings, transformers, and reinforcement learning for human feedback. And these elements will actually tell us how to be judgmental and encounter and deal with those claims. For example, if ChatGPT actually is a useful tool for us. Because these three articles tell three different stories about the same paper where it has a different conclusion. So everybody was telling us a different thing about it. But this technology is everywhere, and the point of this abstract of this paper is that the people using ChatGPT, like the people who are like on a higher skill level, I just put it like in a more like ground down to earth point, was that they used it, and the way they were using it increased their productivity. Whereas the people on the lower end of the spectrum, with a lower level of skill, it didn't really help them, though it gave them the feeling and the idea they were better performers at their job. And this is what we're going to deal with as humanity, right, in the next years. So what we would really like to talk about today, in the next 18 minutes or so, is just to give a presentation of these three core ideas, starting with embeddings, or in another way, how computer can learn and represent for themselves meaning like semantic meaning. Because you see here, we do like animals a lot. We usually talk about beavers, but the time we're going about with seals, right? We all know that's a seal. And we know that this word matches to that thing in our head. That's the meaning of seal, the semantic meaning. But we know that AI models and models in general and machines only understand numbers. So how do we represent seal, the concept of seal, inside the machine, right? And this goes back to back in the very beginning of the 60s, where we were trying to basically just build dictionaries as arrays, extremely sparse arrays, where we had just seal, there was a vector that had like every element set as 0 except 1, which was the position in the alphabet where seal was. And then book was another vector where there was like a 1, so like a positive index, in a whole extremely sparse vector, so a vector that has so many zeros inside, right? But it was highly inefficient, and it is highly inefficient, because there is a lot of, they call it sparsity. So like, imagine like if there are like, say, 300,000 words, maybe even less, let's say 30,000, that would be just enough to represent the whole dictionary of the words that we use. You just have like something that is always flat, and then there's a point in there. So, and every word is unique in this dimension. So imagine that you explode this in a cube, right? You see that you have just one dot in this whole enormous representation, where information is only in that point, and the rest is just empty, right? And so this is an extremely inefficient representation of words in the space. But it has three main, I really, like, this is like the technical problem. The real problem is something else, right? And we kind of know it, right? But I will get to that later, because there is still something we need to figure out. If you give this representation, how do you represent meaning in words? How do you build up the words, like the meaning of a whole sentence? Provided that even if this worked, how can we make sense of a word that said like a seal is on the ice, right? If we just represent it as a sequence of vectors, or these empty sparse vectors, we're going to make only so much out of it. And one of the key novelties in this sector was by this extremely renowned paper, which is called like Word2Vec. That was developed by some guys at Google. Like what ChatGPT came out of was basically 10 years of research by Google. Like folks at OpenAI did a great part in the last bit, but like the real, like down to earth, the most profound things that came up was from papers from Google. The first one being Word2Vec, which was a way to represent words in dense vectors. So not like sparse vector with 0 and 1, just 1, 1, but like as a vector of dense numeric, so like a series of weights, basically, numbers from 0 to 1, for example. And this is basically something that you might have seen fairly well around, more than once. So basically, with this neural network that was able to basically take a word and assign weights to it. And this, you see here that these are not like dense, like no sparse weights. They are dense weights. We say dense because every element has a number in it. And this makes it possible that if you take man and subtract woman, basically the numerical representation is something that gives like the idea of a, like, say, a human being. So if you add king, the weights of king to this, you will obtain queen. Or actually, if you do it like one way around, you see here that basically we can reason about words numerically, like in a space, which was something that was extremely hard, numerically inefficient, and really hard to picture in our minds to do with sparse vectors. Now, basically, if you have like the same space, like the same number of dimensions in space, and every dimension has a weight, then you can start to realize that this distance between man and woman should kind of always be the same, approximately, right? Between every every pair of words where there are like the distance like between man and woman. So you should like maybe teacher is not like a proper example here, but you see this was worked really well between king and queen. There is a series of outstanding YouTube videos by Free Blue One Brown, Grant Sanderson, who also gave a wonderful commencement speech after the graduation of the students at Harvard this year. And it was also making another example. If you take the word embedding, so the vectors of Italy and Mussolini, and you subtract Germany, you will get the resulting point will be somewhat close to Hitler. Right? I mean, this is a bit creepy, but this gets you the idea that if we have these richer representation of numbers in space, we can start mapping words in the space and say that some words have a certain distance between each other. And this is how basically words are represented in the vocabulary of ChatGPT in the mind. Every word we use actually a sub-part of a word, which is called a vector token, but it doesn't really matter right now. It's just a series of numbers along a certain number of dimension. The more dimensions, the richer this representation, because it's like a bigger fan of possibilities where you can capture these sfumature, these shades, right, of meaning. And the more they are, but of course, like the more words they are, and the bigger number the dimension there is, like the bigger this vocabulary, and the more expensive the model. And this is why these models are becoming bigger and bigger and bigger, right? Actually, they were for a little while, because you need to capture all of the richness in our vocabulary, and this is what allows us not only to capture the words like not only like lexically being a part of a vocabulary, but like semantically, with all of the wealth of meaning that we are used to give them. And this is like a practical explanation, and forget about the numbers, this is just like for mathematical purposes, but the point is that the meaning of this word here is given by the words that stand like around it. The way this word-to-vec model works is, and how it produces these numbers, is by ingesting a huge quantity of raw text and trying to, given a word, and its context, to basically guess the weight, the position, and progressively adjust the position in this huge space of every word. And this sounds pretty much abstract to you, but I think that the next image will actually be of help to you. This is how this magical model learn how to basically put the words in the right vector space. Basically, what we do when we train a word-to-vec model, and the first step that we train like the model that makes up ChatGPT, is in this way, like what we used to do to learn, I don't know, il congiuntivo, like verbs, or learning words in English, or even more sophisticated temporal verbs or conjugation of the verbs in our own language. Basically, we take all of the text in the internet that it's either public or they forget that they used it, or they don't know they used it, and they take it and they just hide some parts of the text and make the model guess the word. And by guessing the correct word, because because if you say remove small here, we know what's the true here, the true value here, the model starts to adjust its so-called weights, which are basically the numbers that we have in these vectors associated with each word, and it starts to basically just guess the right word given a context. So, and this thing is called masked learning or masked language modeling. But this is just to give you an idea, like how closer to our intuition of how we make basically people learn, like some concept in Italy, we were able to model it for machines to start building a representation of them in mind, using a whole lot of text, unstructured raw text that we have in mind. And they're all available, and it's really easy to use because we already have all the text from, say, Wikipedia, and we can just hide a bunch of words somewhere and have the model figure out which are the words. And we can even do it even better and better, giving them it's called negative examples, so words that they shouldn't be using at all, that do not appear together. And by this kind of training, given a lot of time and compute resources, you get this. And this is outstanding, but the theory behind it, and I'll give you a couple of references, it's just very easy to grasp, I would argue. Because this is basically a really kind of procedure that we were able to codify, like program, and have a system learn it. So we were able to extract from our own experience and put it basically in a machine and inform it. Just to keep in mind, the model isn't learning these things on its own. We actively model this, right? We were able to simplify or extract an algorithm that captured some of the shades of the way we learn and put it in there. And this is basically the same way that models learn how to use images as well, because they hide pieces of the image and they have the model reconstruct them. But this leaves us with another error: synonyms. We know that a seal put a seal doesn't mean, it doesn't always mean the same thing, right? And using this richer context and way of learning from the neighboring words, we can also build a representation using transformers of synonyms. Because the problem with this approach here is that seal here with this number can both be the animal and the physical stamp, right? And when we do this rich representation, it can also be the same because man here may not be an example, but seal here would have the same representation with both. And that is the novelty that was on the very, very famous paper of this is Bert, but mostly before, like the transformer, like the ever famous paper, attention is all you need. What this paper did was simply, and get me there we go, use the context, and from all of the context that there was before, just select the most important words out of it. And I think there is a more important representation here, where basically your query is basically all the text that comes before, and the keys are all a bunch of values, basically the key and a value, are used to establish which one is the output. This is a bit complex, so let me just rephrase it. The idea behind attention mechanism, which made possible BERT, which is the model that is used on Google search when you type something and it suggests you, maybe you meant something else. That's because this model basically guesses the right word and says, okay, maybe you weren't really looking for this one. Or it is the model that is used to give you most pertinent results because it learns how to rank stuff, because it has this comprehension of the context that is given by something that is a bit more sophisticated than this. But it has the output is just the same, but the way it combines this value is a bit more richer than that. And the idea is just that when we are trying to predict the next word, when you say ChatGPT, and give it an input of a sequence, when it needs to predict this word, it uses every word that comes before it, and let's just say it has saved somewhere in basically its memory a series of combination of weights of the words that came before, and it multiplies them to fetch the key value, the value afterwards. And in this rich representation, basically we see that when we try to predict the next word, different words have a different weight. Which means that, for example, suppose this sentence is, can you please tell me what, I don't know, or tell me a story that of a fairy in a garden. And then, and this is the word, basically it is exploded in all of its components, and the model has learned to, not only to produce these embeddings, these dense representation of words, but to associate multiple embeddings, right, multiple vectors to each of those words that make up the query that you make, and can selectively use those to pick up the most important pieces of the most important values, most important elements of the context. So to put it in another way, it's using the elements of the word, and it has learned that given a certain word, some other words in the context that came before are much more important than others. And if you think about that, that's basically what we do, right? Because now you don't really need to remember every single piece of word that I said. You just remember the key values. You remember the word embedding. You remember the word mass modeling. You might remember dense vector. And we were able to put into a machine this kind of logic of, given a certain word, recognize which other words are more important than the others, and use those to make a prediction of what comes next. This model was originally actually used for translation. And if you think about it, that's really intuitive, right? Because if you're trying to translate the European Union in English or in French, l'Union Européenne, the model needs to know the English word, and it was the European Union. So when it needs to translate l'Union, it will know that the next word is Européen, like European, so it will be more likely to output a word that has more pertinence to the context that there is when you were trained that. This is a bit more abstract. This is by far the toughest topic. But the key idea is the model was not only trained to learn representations of the word in a numerical space where you can basically do arithmetic operations, but only to rank, to give a set of weights where you give basically the importance of a word in given a certain context. So basically when a new word comes, only the weights that are most important for that word are picked, so that it can use those weights to make the new informed prediction about what comes next that is more relevant to the context that came before. And the last bit is how GPT came to be. What I'm telling you right now is this huge bit. And this is something that takes quite a long time. For example, something like in around of months, possibly. something that takes a huge quantity of text, all of the data there is on the internet, even what they tell you they didn't use, or what they can't tell you that they used, or they don't remember how they was trained to. It's raw text, poor quality, the worst thing that happens, or the worst thing that you can read on the internet. Maybe some of you heard of Minerva, like an LLM that was trained in Italy, from the La Sapienza University. And then a couple of articles were starting to pop out. But this model speaks like Generale Vannacci, so it has like racist content and slurs. But that's because like the raw content it was trained on was just everything that it saw that we produced and put out on the internet. And it learns like we used to learn past tenses in school. And this takes months and lots of GPUs, lots and lots of compute. And it takes like, orders of tens of millions of dollars, but it's getting lower and lower because we're getting better at it. And this produces a base model, which is something that it is unable to be used as a product, as ChatGPT. So we do 2 more rounds of training with much less data, of bigger and bigger quality, of higher and higher quality. The first one being, it's called supervised fine-tuning, where you see here we went from trillions, so thousands of billions of words, to just maybe 1 million of words in total, maybe 10 million. So like 3 orders of magnitude less, or even more, 5 or 6 sometimes, to make the model learn how to speak in a helpful assistant. We call it like in instruction format. So how do I do this? And the model learns how to respond to the structure of question and answers. And then by the end of this training, that takes like a fraction of what it used to be doing, like from months to days, it learns how to properly answer in a format that it is useful as an assistant. But then it doesn't really know how to give the most appropriate answer, right? That's why we see like maybe producing answers that don't really matter, or they use irrelevant context. So they suggest you to drink or to use glue on top of your pizza to make it like better, right? There's something that really happened in the past few days if you were on Reddit. The last step is another extremely round of, and the thing that we know the least amount of, which is called reinforcement learning from human feedback, which is basically still an undocumented procedure that can be undergone in different ways. But the most time-consuming and the original one that was used, very likely used by GPT, like by OpenAI, is to have people writing questions and answers, like producing a bunch of answers and telling which one was the best answers out of all of them. And train a model to rank the most appropriate answers, and then do another round of training along the same order of magnitude as the second one, the instruction fine-tuning, so that the model can learn not only to give an answer in an appropriate format, but the best answer given a set of possible ones. So not only the model has learned how to behave like an assistant, but to behave like an helpful assistant, somebody that can actually give you proper recommendations. And basically, this is all there is, right, to ChatGPT. 3 phases: learning using embeddings and transformer architecture to give context, learn context, and be able to build a semantic representation. A second step, which is everything that you need to make it behave like we are doing, answering questions or conversing, basically, like chatting. And finally, a step about which we don't really know much right now. There are some alternatives and some research has been done, but basically this is like the step that we know the least amount of, because they're a little bit more secretive about it. Even like the Llama papers, like the open source models, don't really do a lot of good, like in explaining us how they did it. Like the code that we don't know it, like how they produce this data. But basically involves using a model that learns how to rank the answers in order like of quality, and then progressively have the final model, which is the reinforcement learning model, basically ChatGPT, almost ChatGPT, right? Be able to produce helpful answers to you. And this is all there is to build a product like that. So my name was Luca. I am an AI engineer in Extreme day by day. I do this kind of things every day, building safe, helpful AI solutions using generative AI. But I'm also an open source maintainer of a time series forecasting library. You can reach out to me through LinkedIn. I would really love to get your feedback, especially about this improvised talk, and if it was effective enough for you to understand the content. So please feel free to reach out and tell me anything you had in mind about this talk and how I delivered it, because I would really cherish for you to have all the tools that you need to deal with these novelties and with this kind of revolution or hype anyway, and have the proper tools to see what we're coming at us and how to handle and see what's behind the mist and what is just hype and what's real value for us. Thank you very much.
Unfortunately, we do not have time for question, but I really, really want to say thank you for this improvisation. So please, another huge applause for Luca.
Thank you.
Thank you again.
Un applauso alla regia.
Of course, of course.
Thank you very much.
We'll be back in 10 minutes for the last talk.
I'll be here for questions if you need.
Just awkward silence. That's all. How have you guys liked the conference so far? Pretty good, pretty good. Is anybody at the dinner last night? Yeah, a couple people. Who stayed out until 3? Handful of people, handful of people. It's nice. It's nice to have the last talk of the day. I was able to sleep in a little bit.
Regia tell us that we can start. So,
Fantastic.
Regia, how do you say Regia in English? Directors, sorry. So, I think you know Scott Chaikin. How many of you already know him? Not everybody. So, Scott is the co-founder of GitHub, and he will share with us some tips and tricks to know how to use GitHub better, right?
Git, but yes.
Git,
A
yeah.
little bit of GitHub.
So please welcome with a huge applause, Scott.
Thank you. Thank you. Okay, so this talk is really going to just throw a lot of stuff at you. I'm not going to go deep into anything. What I really like about conferences is coming out with little things that I want to research later, right? So I'm not going to go into a lot of depth about anything, but I'm going to talk about Git. So a little bit about me. As she said, I was one of the co-founders of GitHub. I wrote the Pro Git book, so if you go on the Git website and read sort of the documentation, I'm to blame for most of that. If anything's wrong, which there are wrong things in there, I apologize for that. And now I'm working on a new Git GUI called Git Butler, which you can go to gitbutler.com and try that out and download that. I'll talk about it a little bit at the end. But most of this is going to be about just plain, pure, vanilla Git. How many of you use Git on the command line? How many of you use Git as a GUI or in an IDE or something? Okay, so it's mostly command line stuff. So how well do you know Git? There are a lot of Git commands, right? So there are 82 what they call porcelain commands. So this will be things like your main, there are 44 main commands, add, commit, push, pull. Most people that I meet probably learn like 8 commands, and they really only use those 8 commands over and over, and most of the ones that you've memorized and use on a daily basis are probably in those 44. But there's a lot of other fun stuff in there. There's manipulators, and you probably use config from time to time, or when you first set it up, reflog, replace, things like that. There's interrogators. There's things that kind of go through your history, like blame or re. There's interactors, like send email, perforce, subversion bridges. There's a bunch of stuff that none of you have probably ever used, but they do exist there for interacting with other systems. And then there's a bunch of plumbing commands. And there's a whole bunch of really weird plumbing commands that I actually use a lot because I'm working on a Git GUI, so I have to kind of go in and see what the objects look like and things like that. But for the purposes of this talk, of the 145, I'm not going to go through any of those. That's a completely separate talk that I would love to do, but it is a level of nerd that I'm not sure that I can hit right now. So what I want to do is go through Git, because most of us, I've been using Git for almost 15 years now, a little over 15 years now, I think. I'm very old, but so is Git. But most of what I do on a daily basis, most of what you guys do on a daily basis is probably very not different than what I did 15 years ago, right? You're still doing adds and commits and pushes and pulls and fetches and stuff like that. So, but it's a very active project, right? There's still almost 10 commits a day, 10,000 commits in the last 3 years. So what has been happening? So what I really want to do is kind of go over that. So this is our agenda. We're going to do some helpful config stuff. We're going to do some oldies but goodies, some stuff that's been around for a while that you may not know about that I find very valuable, that are not defaults. We're going to go through some new stuff that you may not have noticed that have happened in the last couple years, or sometimes in the last couple months for some of them, and some big repo, mono-repo stuff, which I find really interesting. Git is actually very good with large repositories now, which didn't used to be the case. And then I'll show a couple of new GitHub stuff and some Git Butler stuff. So again, like I said, I'm just going to shoot a bunch of stuff out at you. It's going to be rapid fire. Take what you want. If you don't want to take notes, you can go to the blog of my company, blog.gitbutler.com, and I have these slides up so you can go through. And there's also a previous recording of this talk if you want to watch it again. My jokes are better in that one. So let's start with some helpful config stuff. So a lot of you may know about aliasing. What I'm going to talk about a lot in the later parts, the reason that I put this in is because I'll talk about a bunch of like command line options that you can give to some of the commands. And usually you don't want to type out all of those command line options. So if you find any of this useful, what you probably want to do is set up an alias. And this sets it up so that you can run, in this case, git stash with 2 A's, and it runs a little bit of a different git stash command, right? So if you have things that you like using, you can set up an alias, and then it just sort of expands that alias out as though it's a git command. So in this case, stash dash dash all will do a slightly different version of stash, right? So if you like using that, you can set that up. But that runs for just about any of these command line options. You can also write your own scripts that do stuff in Git, and you can alias it with a bang in the front, and then if I run git bb, it will run this shell script, right? And so if you want to write your own sort of Git commands and pretend like they're Git commands, you can reference your own program that way. So this is an example. If you go to my gist, that I run git bb, and it kind of gives me a different version of it shows branches in a different way. So I don't really like the default way that Git shows you branches. I think it's like an alpha ordered and all in one column. So for this is nice, I have ahead behind information, which I find very valuable, like GitHub does and really Git almost never does. And then show the branches, but then it orders it by the last commit, and it also shows, I don't know if you know this, you can put notes sort of on branches, but they're rarely shown or used for anything. So I'm actually pulling them out and showing them on the thing, so you can kind of say, this is what this branch is doing, which is kind of nice as well. Okay. The other config thing that I want to share is these conditional configs. So a lot of you are open. Raise your hand if you work on open source projects. Okay, so a lot of you work on open source stuff and have a day job, and sometimes they don't entirely overlap, or you work on them at the same time. One thing that you can do is, you may know that Git will look for configuration values globally, right? So it'll look in your home directory for your config values, and then it'll look, you can overwrite them on a per project basis. But you can also overwrite them in a subdirectory. So every project in that subdirectory can look, so it'll look in the project, and then in the subdirectory, and then in the global configuration. And so if you want to put, say, all of your open source stuff, you have an open source Git config, and you have a work Git config, and you put all your projects into your work projects under work and your OSS projects under OSS. Whenever you do commits and stuff, it'll use those configuration values for your email address and your name and stuff like that. So if you want to, if you have stuff you don't want people to know who you are, right? You have a pseudonym or something, you can do that. So here's a simple example, right? Under OSS, I have a .git config. I put in that if include value, and then when I'm under there and I run git config, it shows this. And when I'm under OSS and I run git config, it shows another one. So when I do my commits, it uses those email addresses. So that's kind of nice. Okay, oldies but goodies, a bunch of stuff that Git has done for a long time. One is git blame. How many of you use git blame? I blame files all the time. You can run -l, which limits the scope of what it blames to a certain section of files or a certain function, or a certain line range or a certain function. So you don't have to blame the whole file. You can say, I just want to blame this particular thing. So -l is just blame a little. So you can say -l lines 15 through 26 on this file, and it will just give you that. You can also run git log -l with the same thing, and it will essentially give you the same information, but in a format of a log, right? So it'll show you the same listing of commits, but it'll say, here's the last one that was done, and the one before that, and the one before that, but only stuff that touches those lines. And so it's kind of a nicer way. If you want to say, what's the story of this function, sometimes the log blame is kind of a nicer way of reading through that story than just seeing sort of the top line commit message of every line over and over and over again in some cases. You can also do this kind of interesting thing where you do a colon and then a string, and it'll try to figure out what you're talking about, right? So if you do a colon and then a function name, and then another colon and the path to the file, it will try to figure out what function you're talking about and figure out the line range for you, which is kind of cool. Okay, but git blame is kind of stupid in lots of cases, because it will just show you, if you take a function, you move it to another file, or you rename a file, it will just see that rename, or just see that, or if you get a new person that you just hired, and they come in and lint all your shit, and now every line is owned by them, there's a couple different ways that you can solve that. One is, there is I forget the name of the file, but you can put in a thing that says ignore these commits, and blame will just ignore them. I forget what that is. I should probably put this in the presentation at some point. But the other thing you can do is give blame a bunch of options. So one is dash W, which is ignore white space, and then you can do dash capital C, which detects lines that are moved or copied within the same commit. So if you move something and then commit it, it will ignore that movement, right? And just kind of go back to whatever like it sees the movement of the file. So it's kind of nice. One of the things that Git does that I don't think I've ever seen a Unix command do is if you give it the same option more than one time, it does more things, right? So if you do dash C twice, it will detect lines moved, or in the same commit, or the commit that created the file. If you give it 3 times, it will do any commit at all, right? So each one of these makes it more expensive, but filters out more crap, right? And so then what you get if you run, let's say this blame, where I can see on this particular, TypeScript class, it looks like Kirill did all of this work, right? If I run it with 3 capital C's and a dash W, then what it does is I can see that Kirill actually wrote almost none of this code, right? These were all written by other people, but we had a lot of refactorings that kind of moved them around, and it will show you what file that change was made in at the time. That file may not exist anymore, but that was the file that was edited at the time that there was the last meaningful edit of that line. So this is a much nicer blame. I would suggest setting up an alias for this if you're using. I always run git blame with this by default because it's almost always more valuable than a normal blame. Okay. The next one, oldie but goodies, is the pickaxe. So if you do dash capital S, you can search for regexes in the patch that any particular commit is introducing. So if you want to see where something was removed from your code, if you remember that I had written some function and then somebody took it out and then you want to go back and find it again, and you remember what the function name or any string in any of the code, you can do dash capital S. I don't know why it's called a pickaxe actually, but people on the mailing list call it the pickaxe. But I can search for a string, or you can also do a regular expression. There's some other cool things that you can do with this type of functionality, but if you look through the docs for pickaxe, it'll show you stuff. And I can go through and say, okay, here's when any commit either added or removed lines that matches files watcher, right? Which is kind of nice. One of the last ones, git diff. By default, will do these lines. So it'll say, you remove this line and you added this line, right? What I really did was I changed a word in this sentence. And it's a little bit difficult to parse this. Now, GitHub will do both of these. So if you look at the diff on GitHub, it will do the line, and then it will also highlight the word that was actually changed within that line in some cases. But on the command line, you can do this as well with dash dash word diff, and it will just it'll do this kind of weird thing here. But it's much easier to kind of parse the change in that line that way. Another thing that most of you should probably, if you do, who does rebase, who rebases their work a lot, like their branches? Okay, so if you're doing rebasing and you don't have this turned on, you should probably turn this on because there's almost no downside to this, and it can be very helpful. Re stands for reuse recorded resolution. So anytime that you do you get a merge conflict and you fix it and you commit it, it remembers that change. It remembers, okay, here was side A and here was side B. And here's how you committed the resolution. And the next time it sees it, it will say, hey, I remember this. Do you want me to just use what you did last time? And it'll use what you do last time. So you don't have to do the same resolutions over and over again. So if you just set it with this sort of global re-enabled, it will start doing it automatically. So if I get a merge conflict, it'll say, hey, I recorded the pre-image, so I remember what this conflict looks like. And then you commit it, and it says, okay, I recorded the resolution. And then the next time that you rebase something or you merge something and it sees it again, it's like, hey, I saw this, and I automatically staged the resolution, so it doesn't even show it as a problem at this point, right? So that's kind of nice. Okay, that's all the oldies but goodies. Git has done all of those things for a very, very long time. How many of you learned something new in that section? Awesome, okay. So, some new stuff. So, I mean, if you guys didn't know that stuff, you're not going to know this stuff. So, a lot of this stuff some of it is brand new, right? So, this is dumb, but I like it for 2 reasons. One is that it's dumb, and the other is because it's somewhat useful. If you run git branch -- column, instead of listing the branches out as one sort of line, or one branch per line of just here's all your branches, right? Like git branch -- r or whatever. This is what it normally looks like to say, okay, this is the branch you're on, and then here's a bunch of other branches and so on. If you say -- column, or you set this config value, column.ui is auto, and the other thing you can do is set a default sorting, so you can do branch.sort, and this is by reverse committer date. So it will not sort them alphabetically, it will sort them by the most recently committed to first, right? And sort of order them, which I find this much, much more useful. Then it'll show it like this, right? So it'll break it into columns. It'll automatically kind of figure out the longest name and say, here's a column format of this, and sort it by last committer date rather than alpha order. But what's very funny is that the way it does this is it pipes it through a new Unix command that Git ships with called git column, which has nothing to do with Git. All it does is take text input that is sort of one line and then tries to put it into multiple columns, right? So you can actually use git column through anything. If you have any output and you pipe it through git column, it'll give you a nice sort of UI formatted textual representation of it with padding and stuff like that. So this is a tool you have on your command line right now. I don't know if you know that, but I find it very funny. Okay, the next one is -- force with lease. Show of hands, who uses force with lease? Okay, then this is really, this should probably be the default in Git, honestly. So here's what the problem set is. I'm sure everyone in the room has run into this. There's Scott and Tom. Scott makes some changes to a file, commits the changes to the file, pushes it to the server. Tom pulls those changes down, gets the new changes to the README. Then he makes some changes to the file and he commits, and then he pushes, right? Totally normal so far. Scott goes to lunch, gets some Aperol Spritz over here, next to the thing, gets a little drunk, forgot what he was doing, comes back, says, oh man, I forgot, I wanted to do this. I'm just quickly gonna amend my commit, and then I'm gonna force push that, right? So this because, this happens. So, fine. Now Tom, has to deal with this at some point later. What you can do, in case you just wanna be safe about it, is you can do force with lease. And what force with lease does is it looks at what your local representation of origin master, so the last time you pushed or fetched, and makes sure that that matches what's on the server. And if it doesn't, then it refuses to push, right? And so this is just, it's nice, right? It gives you an idea that, because this can happen real fast, right? Like you can do a fetch and then make your change and then do a fetch again. And then in the time it takes you to write like git push, somebody's pushed, right? And so it's kind of nice to just have this thing in there that you don't kind of screw it up. There's also another command called force if includes that is even stronger, right? So if you happen to have some background fetching thing or something like that, or you fetch in the meantime and then you push, it will match, right? And it'll force push it. Force if includes looks through your ref logs and make sure that you actually merged it at some point or that it's in the history of the branch that you're trying to push. So it's even safer, but it won't work unless you also do force with lease. So if you want to be very safe with your force pushes, you literally have to type out all of this stuff, right? So this is where the aliases kind of come in handy. The next one is git maintenance. Sorry, I just want to keep doing the show of hands because I'm curious sort of, what the state of the art is, especially in different communities. Who uses Git, who knows what Git maintenance is? Okay, so what I want to encourage you to do is go on your laptop and type Git maintenance right now on whatever projects that you use a lot, because all it's going to do is make everything faster. If you type git maintenance start, what it's going to do, sorry, not git maintenance start. All it's going to do is add in this config, this little config value into whatever project. And what this does is a whole bunch of stuff, right? It changes sort of the defaults for commit graph stuff, for prefetching, for how it packs loose objects, how it does incremental repacks. I'm going to go into the important ones of these a little bit later, but essentially what it does is set a whole bunch of values that try to make a lot of stuff that Git does faster behind the scenes that you don't really have to worry about. So I'll get into what those are in 1 second. Work trees. So one more time, who uses work trees? 1, 3, okay. So work trees are when you want to work on multiple branches at the same time. Now there's a couple different ways you can do this, right? And so this is the alternative to, say, stashing a work in progress and checking out another branch and working on that and pushing it up and then, sort of stashing back what you had, or doing a work in progress commit or something and switching back and forth between branches. What you can do is have multiple subdirectories that have different branches checked out on them. So you could do this by cloning. You could clone to 2 different projects, right, and be in different branches. Or you can even clone locally. So you can, I don't know if you know this, you can clone like clone, tilde / my project name, and then it puts it into a second repository. And then the remote, if you push, goes into the other subdirectory, right? But this is kind of cooler because it kind of does that, except it uses the same object database. So any work you do in any of the work trees of your project is seen globally by all of the other work trees, right? So if you commit on a branch and then you go to another work tree and you say, hey, what are my branches? It's going to see the work that you did in the other subdirectory. So you can have lots of different working directories that have different branch states on them, and all the work is seen by all the other ones. So if these are our branches, if we have my patch series and we have main, and we want to check out a new branch, but we don't want to stop kind of what we're doing, we can say get worktree add, and give it a subdirectory, and give it a branch name, so in this case, bug fix, or you can just check out the branch you're on and then go over there and switch if you want to. And then if we go into that working directory and we make some change and we do a commit, and then we go back to our other one, we can see, if we want to get branch, that we see the branch that we were working on in the other one, right? So it has this sort of shared state, and it also shows it a little bit different, so you know that this is in a work tree somewhere, which is kind of nice. And then if you want to see what your work trees are, you can say work tree list, and it will say in any of the work trees, and it will say here's where all of the different branches, the different work trees of this particular project are, and you can go and work in any of them if you'd like to. And if you delete it, you can say work tree prune, and it'll just delete the references that don't exist anymore. Okay, fix up commits. So if, for those of you who raised your hand when you were doing rebase, if you rebase sort of a patch series a lot, this is a really, really nice tool to help manage that. And so what it does essentially, so the concept is, let's say you have a couple of, actually I probably have a thing for this. The concept is, let's say I have a patch series, right? So I have these 5 patches in some branch or something. And I send them to GitHub, and somebody gives me feedback and says, okay, here's the changes that I would make, change the documentation in some way, and change the client-side thing, and change the test of the new feature. And you're like, oh my God, right? Because now you have to do sort of an interactive rebase and stop at each of those points and commit stuff or whatever. So what this does is help make that process much, much easier to kind of squash those changes down into those commits. So in this case, let's say we want to edit the documentation, which is way at the bottom, right? So an interactive rebase, we'd have to kind of go down there and do that. What it does is you say, hey, here's my change, and I'm going to do -- fix up. I'm going to commit it, but I'm going to do -- fix up with the target of where it goes, right? This is the one that I'm supposed to be changing. And so I can do that several times and say, I can even do them to the same commits, right? I can say, here's a change, it goes to this commit. Here's a change, it goes to this commit. Here's a change, it goes to that patch. And then, I zoomed in case anybody's particularly blind. And then, now we can see what it did is it gives us a new commit on top. So this is mostly how how people using GitHub kind of do PRs, right? Is they're like, I fixed some stuff, and then they push it, and then GitHub PRs like a unified diff, and you're like, okay, I guess that's fine. But then when you blame, you kind of come up with fix some stuff, right? Which is not as valuable. So in this case, it does a specific message, and if I run rebase, either interactive rebase and I do, or just rebase without interactivity now. This is actually a newer one. You used to have to do it with interactivity. So if you have a very new version of Git, you don't have to do the -i. You can just say -- auto squash, and it's going to take your patch series, it's going to rearrange them, and it's going to do the proper squashing, right? So now it's taken that top one, and you can see it's changed the SHA here, right? And then rebased everything on top of it. But it took that change I made and it squashed it down into this commit. So it's a nice way of handling sort of rebase series. Okay, big monorepo stuff. So if you happen to work with very large repositories or mono repositories, Git has some really nice tooling for this now. It used to be very bad at this. It used to be essentially anytime you clone like the Linux kernel or something, you'd have to get the entire Linux kernel. You couldn't really make like just check out this directory or just get some smaller version of this that I can work on. Most of this has come into Git because of Windows, because Microsoft tried to move or has effectively moved their Windows team to using Git. So Windows is written in Git now, which I'm not sure if anybody knew that, but that is completely ridiculous to me. But in order to make that work, Windows is a very, very, very large database, right? So they have 3.5 million files in a checkout. and it's 300 gigabytes. So you can imagine trying to clone, like it's your first day at Microsoft and you come into work on Windows and they're like, just run this command and then go to lunch and we'll see you tomorrow, and you can start working on it tomorrow. There's also 4,000 engineers working on it every day, right? So there's a lot of overlap, there's a lot of work going on. So in order, again, in case I didn't say that correctly, here's some numbers that I just said. In order to fix this, what they did was they tried a couple of different things in series that kind of worked around and on top of Git. The first was a virtual file system, which is similar to how Facebook uses Mercurial. They have like a virtual file system that Mercurial uses in order to make this type of large repo work doable. And then they moved that into, they didn't really like the way that worked, and so they moved that into a project called Scalar, which kind of worked on top of Git, and specifically on Windows. And then they backported all of that into vanilla Git. So now everything that was in Scalar is in Git, and you can use all this stuff. So one is prefetching. So when you run git maintenance start, one of the things it runs is every once in a while, it will fetch from the server. It will not fetch your refs. It will just fetch the data and keep them in hidden refs, so that when you do a fetch, it will update all of your refs, but you already have all the data. So the fetch looks like almost a no-op, right? It'll be like, hey, I want to fetch this thing, and it's like, this is where the heads are, and it's like, you already have all these objects, so it's instantaneous. You can look at them if you do for each ref and look for prefetch stuff. They're under this ref's prefetch, not under ref's heads, but it downloads all of this stuff in the background, so you don't have to think about it. It also writes commit graphs, which is like a little database that makes walking the commit history faster. So in this case, if you have a really large repository, a git log -- graph, before it renders anything, it's going to take like 10 seconds because it has to go through and figure out what the graph looks like before it can show you the top line. If you write the commit graph out, it kind of just takes the commit data and the walkability and puts it into its own little data file and keeps it up to date. And then the next time you run it, it's still slow, and then the next time you run it, it's incredibly fast, right? And so again, git maintenance start will just do this on fetch all the time for you. So all of your ref lock or all of your rev walking stuff is just much faster out of the box, and you don't have to do anything with it. You can turn it on like this: fetch, write, commit graph true, or you can run the git maintenance start thing. The other thing is, if you have a lot of files in your working directory and you run git status, it has to stat every file to figure out what the M time is to see, did this file change? But with git maintenance start, with the file system monitor, it will run a daemon in the background that looks for inode changes and will keep a cache of that, so it doesn't have to stat every file. So this is part of the way that how they got away from the VFS stuff is to make this fast. So you can turn this on with core.fsmonitor true, and then essentially the next time that you run git status, it's going to fire up this daemon in the background, and it'll sit there watching your file system and keeping this log of when you run git status, it becomes much faster. So this is a 11-second git status, right, on a large checkout, and then I turn the FS monitor on, and again, the next time it's not that much faster because the file system monitor has to fire up, and then the time after that, it's half a second instead of 11 seconds, right? So if you have a lot of file checkout, but even if you don't, it's still faster. So you might as well, unless you really don't want the daemon running. This is on Chromium, so it's 500,000 files. And then the last one really is partial clone. So if you want to clone the Linux repository, it's 4.5 gigs, right? So it's not nothing. It takes a little while. You can do this thing called filter blob none, which doesn't give you any of the file contents. It just gives you the commits and the trees, right? So if you do this, it's just going to get this stuff you need to sort of check out a working directory, but it won't give you all the other files in the history. It'll just leave them on the server. So if you do blob none, then instead of 4 gigs, it's 1.5 gigs, and it takes much less time. It has to do 2 fetches, though. It has to do one for all the commits in the trees, and then a second one for all the blobs for your working directory so that it can populate your working directory. You can keep going and say, don't give me any trees either, which doesn't give you any of this stuff. It just gives you all the commit data and then whatever it needs to check out the head. And this does 3 fetches, but now it's only 600 megs, right, rather than 4.5 gigs, and it goes much faster. The downside of this is that if you run a blame, and actually kind of the cool thing, if you run a blame, it doesn't have any of those file contents, right? So it can't really do a blame effectively. And so what it does is it just keeps fetching every object that it needs. As it sees that it needs it, it will fetch it from the server on demand, right? So in this case, on the Linux kernel, on this file, a blame was 4 seconds versus 45 seconds because it had to get every single version of the file that it thinks that it needs to look at it. But that only happens the first time. The second time you blame it, you already have all those things locally, so it's fine. There's a lot of other big repo stuff, and GitHub and Microsoft have blogged about this. If you're interested in any of this, it's kind of fascinating, but not a lot of you probably use that. And then the last thing from big repo is monorepo stuff. So if you use a monorepo, which is having all your projects in one repository, there's a sparse checkout that you can say just check out these 2 subdirectories of this large project or something like that, and then all of your commits and stuff, your statuses are all faster, your commits are everything's faster because you're working with fewer files, right? So if we look at a status that's 5 seconds, and then we run git sparse checkout set, and then the 2 subdirectories that I only want build and base, it'll take all the rest of the files out of my file system and let me just work with those, right? And then when you run stuff, it's like, okay, you're in a sparse checkout, you only have 2% of your tracked files, right? That's all you have on disk right now. And then finally, some GitHub stuff. So there's a lot of stuff on GitHub. I have been using GitHub for a long time, but I haven't worked there in a while. And setting up some new repositories, I've found some things that I didn't know exist. There's actually a lot of little triggers and buttons and stuff that you can do now that are interesting. One is allowed merge types. There's 3 different merge types you can do on GitHub when you hit like the merge button. But you can say which ones you want as an administrator to allow for your project, right? So you can allow squash merging, which is taking the whole branch and making one commit out of it, so you have a linear history. It takes the whole PR, so then it doesn't really matter if you're doing patch management and stuff like that, because the whole thing's going to be smushed down into one that was like, this is PR 45, right? Regular merges, and then only allow rebasing, right? So it'll only rebase, when you hit the button, the only thing it'll do is rebasing. I have actually all of these turned on. You can say what the default message is for squash merging. I have all these turned on, so I can choose which one I want to do when I merge a PR in my project, but you can say only allow one of them, or only allow 2 of them, or something like that, which is kind of cool. There's also auto merging, which is one of my favorite features, actually, that's relatively new, which is if you have a bunch of CI running, and you have a PR, and you're like, if this passes all my CI, I'm gonna hit this button, right? And it's like, no, go get a beer, come back, make sure that CI is done, and then we'll let you hit the button. Until then, it's grayed out, right? So now they have this thing where you can say, you can hit a thing that essentially is a conditional merge, right? It's like, if it passes all the CI, then automatically merge it at the end of that process. And you can set which tests it's checking for in order for that to be true or not. I love this feature. I actually use this a ton. Linear history. For those of you that are rebase nerds that really love having a completely linear history, you can enforce it so people can't even push merges to the server. So one is turning off the merge button sort of on the UI. This one will actually stop it at the server level. And if it sees merge commits, it won't allow the push to happen, which is kind of cool. And you can also require signed commits and things like that if you use sort of GitHub as this massive GPG keyring, right? Which is doable. And then the other thing that I actually just used today was GitHub actually advertises all of the PRs, all of those heads as essentially pseudo branches, even ones that are PRs from forked repositories, and you can directly pull them in if you want to. So if we look at sort of the remotes, like this is some branch called inertia. If I look at all of them, though, on GitHub, it actually has all these refs pull, and then the PR number, and then the merge and head SHAs. So if I want to directly pull something in without kind of, to test it out locally or something like that, I can run git pull origin and just say pull my PR number and head, and that will pull it into whatever branch I'm in, or I can fetch it if I want to, right, and kind of take a look at it. But I don't have to figure out what the branch name is that the PR is based off of. I just need the number. And that's it. What I do, the project that I'm working on right now is also on GitHub. You can check out sort of the source code and look through it and test it out, which is a Git GUI. And it has another interesting approach to essentially the work tree problem that I was talking about before, except for instead of having all of your branches in different subdirectories, it solves the same problem, but it puts all of your branches in the same subdirectory, and we have sort of a smarter index and head system, right? So in this case, this is kind of what the GUI looks like. It's dark mode because we're cool. You can switch it if you'd like to. But each one of these lanes is a branch, and they're all essentially pseudo-merged into your working directory, right? So when you work, you can take a file and you can sort of drag it into another lane, and you can commit it there, and you can keep working and figure out where you want your changes to go, and commit and push them all independently, right? So if this is my feature implementation and this is my bug fix, you're working on a feature, somebody's like, hey, I have a bug, I need you to fix it. You don't have to stop what you're doing or stash stuff or something like that. You just hit a button, create a new virtual branch, do your work in there, commit it, push it up, and then go back to what you were doing without really changing your flow. And then when you push them, they go into sort of new branches on GitHub or GitLab or whatever you're using. Don't use GitLab. But they look like that was the only thing in your working directory at the time. So it's almost like interactive adding, but much more interesting and powerful. If anybody wants to talk about implementation of this, this is all in Rust. I'm a new Rust person. I'm forced to use it in order to get this to happen, but I do love talking about Rust now. And that's it. You can find that on GitHub if you want to check this out or see an example Tory project for a sort of cross-platform GUI. That is all. Thank you very much.
Thank you very much, Scott. We have a lot of questions for you. So get ready. The first one, do you use Git worktree and what do you think about that?
I don't use Git work trees very much because I use Gitbuilder, and so most of the time it isn't something that I need. And also we have a lot of build artifacts because it's a Rust thing, and every time you do a work tree, you have to redo the build there, which you don't get if you're sort of stashing branches. So because of the output artifacts, I prefer to use one working directory for stuff, but I do find a lot of people find it very cool. And I actually learned about it after, I knew it existed, but I learned about it after building Gitbuilder and then people being like, it's just like work trees. And I was like, kinda. But so I like to educate on it because a lot of people don't even know it exists. I didn't even really know what it did. So yeah, the answer is no.
Okay, then can you configure the blame alias -c in the git blame VS Code extension?
So I don't use, the VS Code extension that I use for Git is Git Lens, which is a Git Kraken plugin. And I think it's very well done. There is a config setting that you can say, well, for one, you can do the ignore. There is a config setting that you can say when you run blame, run it with these options. I don't know how to find it, but I'm told it is there. So I don't have it turned on. I would like to turn it on. I can't quite figure out how to do it, but I've only spent like 2 minutes researching it. But it does exist, I'm told.
What is the difference between force with lease and using nothing?
Force with lease or using nothing? That is a good question. Using nothing will not, hold on. Using nothing will not push it if it, oh, that's a great, what is it? Using nothing is essentially will not push it if it doesn't match. No, if it's not in the history of the thing you're trying to push, right? And so if you do git push, and it sees what's on the server, and then it looks in your history and says, okay, this is upstream, then it'll allow you to push it. If it's not upstream, then it won't allow you to push it. If you do -- force, even if that's true, it will allow you to force push it as long as the last time you communicated with the server, it's just trying to make sure you know what you're doing, right? That you've seen the SHA on there, and that the last time you fetched, it came down, and so you know that it exists, right? As opposed to I don't know that it exists.
Is it true that Linus is working on a new tool to replace Git?
I highly doubt it. I don't think he doesn't seem to care that much about version control these days. Nobody seems to care that much about version control these days. I think everything has been Git for so long. That's kind of why I got interested in the project of trying to rethink what are some interesting things that you can do in version control, but that use Git because the Git ecosystem is so prevalent. But Git is really just a database, right? You can write these commits and trees really however you want. You don't have to use the index and the head and all of the refs and stuff like that. But I don't think he didn't even care about version control when he wrote Git, right? He really just wanted a way to do tarball management easier. So I don't think that's true. There are some really interesting things that are happening in version control world that I'm stealing ideas from for what I'm building, like Jiu-Jitsu. If you're interested in nerdy version control stuff, Jiu-Jitsu is one of the coolest things out there right now that is from Google, but it's not really prime time, but it's super, super fascinating. And then Facebook has sapling, which is another nice way of doing sort of stacked patch sort of management.
Okay, then, do you know why GitHub requires force push for amended commits?
I mean, all Git servers require force push for amended commits because it's not in the history of the thing that you're trying to push.
After a commit, how can I see the file diffs against origin before pushing them?
How do I see the file diffs against origin before pushing them? I mean, like, what? Okay, you want to know what you're about to push, and so you're on master, and you want to see what's the difference between my master and origin master. I mean, you can do git diff origin master dot master, right? And then that will, or maybe it's 3 dots. Does anybody know? Is it 2 dots or 3 dots? I always forget the difference. It's 3 dots, and so it'll say, here are my 2 heads, compare them, but only show me stuff on this side, right? It essentially what it does is try to figure out what's the merge base between the two, and then diffs the merge base, like whatever the first common ancestor is, to the side that's the second argument you give, right? So you could kind of manually, this is what GitHub does by default when you push something in like a PR, is it's not comparing it to the target, it's running back through the history and finding what's the first commit they had in common, and then what's the difference between that one and then the head that's in the pull request. So you can do that on the command line if you want with git diff, origin master dot master. That will give you that. You can also do that with git log, actually, if you just want to see the commits that are on that side, which is also nice.
Okay. Git source code is remotely stored on GitHub. Is GitHub project as well?
Is GitHub stored on GitHub?
It says Git source code is remotely stored on GitHub. Is GitHub project as well?
I'll interpret that. I'm not sure the second part. The Git project is on GitHub, but it's more of a mirror. So the Git project and Linux, actually Linus has his Linux tree on GitHub as well that he uses. At one point, the nicest thing he ever said about GitHub was that it is a not terrible mirror. So, but I don't think they do it in a different way where everybody kind of keeps their own trees. Some of the maintainers or people keep their trees on GitHub. But they collaborate over a mailing list, so they don't use PRs and stuff like that. So they don't really care where it is.
Does Git Butler use a database like SQLite or something, or just Git commands in a nice
So we were using SQLite for some speed up stuff. We ripped all of that out because the complexity wasn't worth what we were trying to do. Right now it's all libgit2 and using the Git database for everything that we want to do. We actually do some interesting stuff that's a little bit difficult to do in Git, and I've seen a lot of people try to do things like this, which is use the Git object database as a database, as like a key value store. The problem is that Git will GC objects that it doesn't see, so everything has to be reachable. So like we have, one of the things that actually our tool has, if you look at our tool. So this is me using, oopsie. Sorry, I can.
Using Discord.
Yeah, that's me using Discord. So this is what the tool looks like. So I can, for example, I have this operations log, so I can see everything it's almost like a ref log. It's kind of the history of everything I did. So when I create a branch or move a file or do a commit or, update, sort of like rebase everything onto origin master or any of that stuff, it kind of keeps this thing, and I can then go through and like restore any of them, right? So if I want to go back to what my computer looked like or this project looked like at 7:53 a.m. yesterday, I can hit restore and it just makes everything look like that. It kind of pushes on the top of the stack. So it has this nice operations log. The way that we do this is we keep all this data in Git, right? So we actually have a separate Git tree that stores all of our metadata and the snapshot of the working directory and everything we need to recreate the state. At any time, and then we could push that somewhere if you want, like a backup of your working directory all the time, right? Like kind of pre-commit history. The problem is that if this isn't in a Git ref, so if you run git log -- all, it'll show this if you keep it in a Git ref. If you don't keep it in a Git ref, then Git GC will remove this data, right? Like once it gets too old, which is really kind of problematic. So we do this really dumb trick where we have a ref log for a thing that does matter, and then in like the second part of the history of the ref log, we keep the head of this, right? So you can't really see it. It doesn't really decorate it the way that a branch is, but Git can see it when it tries to anyways, dumb shit like that can be done in Git. It's a little hard to kind of work around some of the intricacies of kind of what Git does.
How is filter clone different from shallow clone?
How is filter clone different from shell clone? I know all those words individually. Can we skip that one? I don't know what that means.
What do you think about submodules? Do you actually use them?
I don't use submodules. Everybody that uses submodules hates submodules. I use them in some other projects, like I use libgit2 a lot, and that has or I use git2rs, which is the Rust bindings, and that has a submodule to Git libgit2. So I have to deal with them sometimes, but I think if you've ever used raise your hand if you love using submodules. There's one guy, two guys, and look at the mustache on that guy. That is a guy who likes submodules. Absolutely, I would have guessed it. That's awesome. Yeah, I mean, you have to love pain, right? Like, it's just very hard to work with. We actually right now Gitbutler won't work with submodules because if we see the .git module file, we're like, you can't import this project because we don't want to deal with it right now. There's just too many different things that are really hard to make work right and aren't surprising. And so I know, but there's no other great way, right? There's like subtree merging, or there's like actually a lot of people just use monorepos for a lot of this now, and try to kind of merge in trees upstream. And use some of the nice monorepo stuff that the Git has now to deal with that. But yeah, there's no great. I'd love to tackle that someday of making a slightly nicer way of doing that. But it's not fantastic in any of the tooling, I don't think.
We have several other questions, but I make you the last one. How many great features of Git are not currently supported by Git guys other than worktree?
By Git guys?
Guys, GUIs.
Oh, Git GUIs.
Sorry.
So some of the, it depends on the GUI. Some of the GUIs support work trees. I think Kraken supports work trees if you want to use that. But most people, honestly, I think most people use Git on the command line mostly, and use GUIs for things that Git doesn't have good user interfaces for, like interactive, like interactive adding, like patch staging and things like that. That's when I would fire up a GUI. That's when most people do. But the thing is that the command line is almost always faster for anything you want to do than a GUI that wraps a button that runs a command line thing. Like, it's almost always easier, and you know exactly what's happening if you're just running the command line thing. So that's why I think most people don't use GUIs. I was interested in building one because I wanted to do stuff that Git doesn't do, but right into the databases, though, it did, right? And so, like, the things that I'm more interested in is what can sort of what can an interface look like that helps the workflow that I want to have, and GitHub can't tell the difference, right? But the way that you actually implement how to create commits and how to create trees and stuff is very different locally. But yeah, I don't know. I don't use any, so.
Okay, so there are other questions, but we have finished the time.
Okay.
I think Scott will stay close by if you need to ask other questions. So please, a warm applause again.
Thank you very much.
Now there is coffee break and then the closing keynote.